Hello, everyone, and welcome to Let's Talk About MySQL Query Tuning. My name is Gabriel Siciliani. I'm an independent consultant, and I've been working with databases since 2005. I started as an Oracle DBA and then moved into the open source world with MySQL and MongoDB. So this is the agenda for today. We're going to first talk about why it is important to take care of our slow queries, and then on the second half of the session we're going to see how to take care of them. So regardless of caching, key value stores, and other layers, applications are still interacting with databases synchronously for many critical operations. That means that any latency added at the database level will translate into our API calls or our user interface. There are numerous studies out there, mapping additional latency with lost revenue or customer dissatisfaction. And of course, we definitely don't want our database layer to be part of that. On the other hand, we have operational costs, right? In the cloud, we are charged by I/O operations, so we know exactly how much more we could be paying for these operations that can be avoided. And in the data center, we definitely want to avoid our databases to uh, affect other workloads. If we are using shared storage, we definitely don't want to accelerate, disk wear out. And we also want to avoid having to, throw additional hardware to a database to accommodate an inefficient workload. Something I realized after doing slow query tuning for many years is that terrible queries are usually spot easily, right, and fixed before they go into production. The problem is are these okay or so-so queries that are running fine on independently or with small data sets, but when they go into production and they start running concurrently and the data set starts to grow, they silently start to erode server performance, and they usually fly like below the radar, right? They are not showing up on our monitoring tools or on the slow query log frequently, so they are harder to spot. Another thing that contributed to the proliferation of slow queries was the adoption of ORMs. Object relational mapping tools are now in charge of generating the queries that interact with the database. And even though in most cases they are doing a good job, there are situations where the queries generated automatically are not great, or they don't work under different situations. Um, ORMs also contributed to the isolation of the developer from the database and from SQL. Right, in the past, applications were developed for a single engine, and developers uh, were more like experts in how that database worked and what features it had, and how to tune queries better. Now we have this abstraction between the application and the database, and the possibility of having the same code working on different DBMS. Um, that expertise in the underlying database server is no longer there. Let's talk about what makes a slow query slow. So first, here's kind of a philosophical discussion, right? Queries are never instantaneous, and we probably want our queries to run as fast as possible within the technology limits, of course. But ultimately, what matters is that our users' um, perception of our product's performance is good enough, and third-party APIs interacting with our APIs are able to do that um, properly. So ultimately, it depends on the clients and customers' perceptions, right? At the same time, the workload profile also matters. Like if user is requesting a report um, with sales for the last year, he's probably willing to wait a bit more than if he's just like checking out Amazon after buying a single product. So you know the type of operation, or the type of interaction with the application also matters uh, in regards to the user perception. So at a very high level, the total query time equals log time plus DB time. Let's review those two concepts a bit more in detail. MySQL has its own internal logging mechanism. So before you are able, your thread is able to modify or read any data, it needs to acquire a log. Um, of course, those logs are in place to prevent any conflicting operations from happening simultaneously. Um, so on busy systems where many threads are trying to access the same rows and tables, that log time could be considerable, or that we're probably going to see larger log times. And this is happening before the actual query execution. The DB time accounts for everything that happens after, right? The actual query execution, where tables are accessed, indexes are accessed, data is joined, sorted, execute functions are executed, um, and also the background tasks are maintained. I'll get into that in a moment. So it's the optimizer, the piece of software that's in charge of generating the execution plan for our query. The execution plan is basically the set of steps that are required to satisfy our query and retrieve the data we are asking for in the format we are asking for. MySQL has a single optimizer for all storage engines, and it's cost-based, which means that if you have more than one alternative or more than one possible plan to retrieve data, then MySQL will pick the one that's less expensive in computing terms, right? Um, the optimizer will rely on table and index statistics to compute the cost for a given plan. That means that MySQL will rely on pre-computed information about our tables and indexes in order to come up with the best, again, with the best estimated plan. So we mentioned background tasks. Of course, there are other things that are happening, behind the scenes while our query is running or is executing, and things that are not directly related to retrieving the data we need for our query. Um, there are operations that are there to maintain or to support specific server or engine features like, again, consistency or durability. Um, you could also have an audit plugin enabled, so operations might need to be checked against rules and logged. You might have compression or encryption enabled for your table, so data needs to be compressed, decompressed, or decrypted before accessing it. So there are a lot of things that are required for the query but are not directly related to the query itself. And there's also buffer management, right? And there's a lot of buffers that are required for a query to run, and those they need to be allocated, they need to be cleaned up, they need to be extended in some cases. So all those operations, even though they are fast in most cases, they add to the total query time. Okay, so far we talk about why we should care about slow queries, what's the impact of having them on our systems, on our customers, and we analyze how the total uh, query time is formed. Um, let's now see how we can manage what process we can follow in order to systematically eliminate slow queries. So here's our query tuning cycle, right? The first thing we're going to do is we're going to set a value in seconds that's going to act as our slow query threshold. And we're going to consider any queries running above that threshold as slow. Then we're going to have to capture those slow queries, right? And of course, you're probably familiar with the slow query log. So that's definitely going to be one of our first options. We're then going to analyze those queries and see if we can determine the root cause of that excessive execution time. And finally, we're going to try to implement any fixes and improvements at different levels to try to take those queries below our threshold. Now, even if your all your queries are running below your target threshold, that doesn't mean that you're done. You would need to regularly run this process in order to capture any new queries that were introduced since the last uh, tuning cycle. Okay, so determining a slow query threshold. For that, we're going to use our long query time server variable, and uh, we're also going to rely on the slow queries status variable. The good thing about the long query time variable is that even regardless of the status of the slow query log, uh, the slow queries counter, again this status variable, will continue to increment for any queries that are running above the long query time threshold. So we don't need to enable the slow query log in order to see how many slow queries we are generating. So again, we're going to work with this slow queries status variable, to make sure that we are not, with the current threshold, we are not generating a huge amount of slow queries. Um, then, if currently, if the slow query log is enabled on the server, it's better to disable it first before actually changing the long query time. Again, because we don't want to run into a situation where uh, we we change the long query time, and a big amount of queries are now running above that new threshold, and we start getting a lot of queries logged into the slow query log file. So we disable the slow query log, and after that we can start adjusting the long query time until we get a steady rate of slow queries. And again, we can easily calculate that slow query rate by checking the slow queries status variable. I would suggest trying to aim for a threshold that generates around one slow query per second. Um, it's important to notice that the initial log time is not actually counted towards the long query time. So if we have a severe locking issue, uh, that's not going to cause the slow queries counter to move up. Okay, so now that we have our threshold, we're going to start capturing our slow queries. So as mentioned before, we have our slow query log variable, which controls if queries are actually logged or not, right? Um, so we have two options for the log. We can send the queries to a file, and of course our next variable will tell us where that file will be stored, or uh, the slow queries could go into a table, and that depends on the log output server variable. So that variable controls not only the slow query log but other logs of all other server logs as well. So again, if we change that value to table, keep in mind that it will affect uh, other logs. Um, but yeah, if in case we are interested in getting the queries into a table, then that's also an option. Um, Keep in mind that aborted queries might be logged anyway. So you're probably, the statistics for that query, I mean, the ones that are logged with the query are probably not going to be accurate, like the amount of rows read or the total execution time. Uh, but you will still get the SQL text on the query log. Um, there are many servers that, because due to the high load, enabling the slow query log is not an option. So for those cases, we could still capture queries by using a TCP dump or by capturing the network traffic. Of course, the main downside of this approach is that we're going to get all the traffic, reaching the server, and not just not just the queries that are running above a certain threshold. So again, it might not be ideal. It might require, tweaking the output a little bit to get something similar to what the slow query log generates. But this is still an option if we can't afford enabling the slow query log on the server. Okay, now it's time to analyze the queries to spot problems. For that, it's a good idea to first, group and sort the slow queries so we can, organize them and focus on those that are either more, slower or more frequent. So a great tool for that, and again, you're probably familiar with this one, is PT Query Digest. Um, so one thing I wanted to mention is that PT Query Digest will be able to both deal with the slow query log output on a file or the TCP dump output as well. Um, that being said, that I run into issues a few times when trying to process TCP dump outputs with PD query digest. Again, since you're capturing raw traffic, even though we are you're trying to format it in the way the PD query digest documentation requires. Uh, Even in those cases, I still saw some issues with when parsing that output. But again, the option is still there, and it works in some cases. Um, the good thing about PD Query Digest is that it will not only group and sort the queries, but it will also kind of standardize the SQL text, right? Extracting the actual values passed to the query. Um, so it will generate like a fingerprint of the query. So then similar queries can be all grouped together and analyzed as one, right? Um, it's very common that you see several instances of the same query with different values on the query log. So in those cases, it's usually kind of better to group them together and to easily notice that okay, this query is running recurrently, and even though it's running with different parameters, um, it's the same query that is running slow. Um, PMM Query Analytics is also a great tool for organizing and sorting slow queries. It is kind of like a graphical interface for our PD Query Digest. It's pretty similar. I mean, the output is similar, and it's displayed on a time bar, so you can see you can see like different slow PD Query Digest snapshots being taken over time, and so you can see you can see a ranking of slow queries for different for these different snapshots. So it's better when you're trying to track an issue at a specific point in time. Again, you can correlate that point in time with the corresponding snapshot. Um, the next thing we should do is to see how the server decided to execute that query, and explain is the right tool for that. Explain will actually show you the execution plan, right? It will show you how the server decided to access the tables and in order, and of course join the data and sort the data in order um, to generate the results that you requested. I added these two options here, extended and partition. Um, Before 5.7, these options were not part of the default output. I think after that they were included by default. But in case you're running older versions of MySQL, you might need to run the extended, explain with the extended option and then with the partition option in case you are working with partitioned tables in order to see the full the full output or all the information that explain can provide. Unfortunately, they can't both be combined on a single command, so you will need to run it twice if you want to see all the information. Um, and of course, once we have the explain plan, we can now try to spot any situations or any tasks for that plan that were consuming a lot of time, or that we're dealing with a lot of rows, and that's what we're going to do next. So the explain output has really a good amount of information, and kind of covering absolutely every possible value for each of the sections, it's beyond the scope of this session. But at least I'm going to give you, a good first, introduction to how to read this output and what you should be, looking for. Um, you know, I wanted to clarify the explain output can has like different formats. You can default is like a table, and that's kind of the legacy format. But there's a tree output and a JSON output, and the JSON output has like a different structure. But so for the purpose of this explanation, I'm going to focus on the table output, which you're probably more familiar with. But again, in case you are working with the JSON output, there's an equivalence between what you see on the table and on the JSON. It's just they're just not exactly the same. Um, so the first thing is that you will see one row per table access. So if your query is joining like four different tables, then you're going to see four rows. So just keep that in mind. You're going to see a row per table. Then the order in which those rows appear are reflecting the actual order in which MySQL read the tables or joined the tables. So the order, again, it is telling you which table was accessed first and which one came after on the join, right, or on the query. Another thing to keep in mind is that unless the extra column says otherwise or says something different that we're going to discuss later, a nested loop join is used. So that means that you can think of a tree table join as basically like three for loops, where each for is accessing the rows of one of the tables. Of course, it's not retrieving all the rows for that table, but the a filtered a filter version of that table. So of course, MySQL will always try to apply the filters first, so less rows are involved on the join operation. But again, just for you to kind of visualize uh, how the server is actually dealing with a tree table join. It's going to try to filter the first table, and then any resulting rows will be joined with the next table, and so on and so forth. So the first thing we that we'll probably should focus on is the rows column, right? That one will tell us how many, of course, how many tuples, or how many rows were read for that table. Um, and of course, like if we're seeing high numbers there, then again, that's definitely something we should investigate deeper. The extended output added this filter column next to the rows, and that one will tell you, okay, I read these, let's say 1,000 rows from that table, but then I applied some filters that came with the where condition, and from that 1,000 rows, I actually kept, let's say, 20% or 30%. So, and that 30% is actually the amount of rows that will be joined with the next table. So if you want to know how many rows are going to be combined on that nested for loop, right? If you want to know how many rows are going to be combined with the next table, you can divide filter by 100 and then multiply that by rows. So that will tell you again how many rows will be joined with the next table. And like if you want to calculate at a high level how many combinations were generated for that join, then you can calculate you know the filter rows for the first table and then multiply that by the filter rows on the second table, and so on and so forth. Because again, this is like a nested for, right? This is a nested loop. So uh, the amount of rows on the first table will be combined with every row on the second table, and the same uh, with between the second and the third table, right? So definitely another interesting column for the explain output is the access type. So access type will tell you how, well, as the name says, right, how the table was accessed. Like, was it read directly, or was it read through an index? um, and how that index was used. So here, the access types are organized from most efficient to less efficient, as you can see at the bottom. Um, and you can see that in like in the first in all the cases except the last one, an index is being used. But it's interesting to see how the index is used in each type. So for the first one, you have the const access type, and that means that uh, the conditions that were passed to the query involved both all keys making the primary key or making a unique key for that table. So there's a single row match, right? Again, because you provided values for all the primary key columns or all unique key columns. Um, and if there was no row matches, then the access type will be null. So you know that if it was const, then you know that a single row was matched. Now the EQ ref, it's kind of similar, but between when you are joining two tables. So that means that the join is being performed by is involving all the columns in a primary or unique key for the second table, right? So again, uh, for every row that's coming from the top table, you know, conditions for all the columns of the primary or unique key are being provided. So the access is pretty efficient. On the third row, we have ref. In this case, the index is being used by but partially, right? Only the leftmost prefix of the key is being used, or in case of primary or unique keys, or perhaps the key is not unique at all, right? It's not unique. So that means that uh, for a given for a given value, one or more rows could match that entry. So and again, and this is also here's you can see another interesting concept about index usage, right? Uh, MySQL could rely on on only parts of the index for filtering data as long as we are referring to the prefix, right? As long as we are not trying to use a column that's it's like in the middle of of an index key. The ref or null access type is similar to ref, but it's telling you that MySQL needed to perform an extra search for rows that contain null values. Then we have range. In the case of range, or as you can see, the operators, right? We are basically, you know, specifying a range of values. It could be like we're passing a range of dates, or we are providing several values in an in clause. So if that's the case, the index can be used, of course, but uh, a range of values will be read and retrieved. The Then near the bottom we have the index access type, which is it's similar to like a full table scan. I mean, it's not similar to full table scan. It will be the equivalent of an index full scan, and it's used when all columns of the query, like uh, either in the projection or on the filter clause, are part of the same index. So in that case, you know, MySQL can avoid, accessing the table, and it could retrieve all data from reading the index instead uh, of the entire table. And then at the bottom we have the full table scan, where all rows for the table are read. And of course, that's definitely something we need to try to avoid at all costs. So we talk about the rows column, we talk about the filter column. In order to know how many rows were read, and then how many rows were left after the filter conditions were applied. Um, we talk about the access type, so we know how those rows were retrieved and filtered. Um, and now we're going to focus on the extra column, which provides additional information that is relevant, especially when you're tuning queries. Um, So the first thing we should check is the using file sort extra data. Um, that is telling you, hey, I was not able to use an index to retrieve the data in the order you requested, so I had to perform a specific sort operation. So this file sort algorithm, uh, it works by chunking the data for the sort operation, and is using the sort buffer for that. Um, if the data is, if the data set to sort is larger than the actual sort buffer, then it will first have to it will have to save the chunks on disk every time a new chunk is processed. So you can probably um, guess that that's not very good for performance if again if you're looking for your queries to to run as fast as possible, right? We don't want to be saving chunks of my results on disk and then retrieving those for a final merge sort. So here's where the sort buffer size server variable comes into a scene, and again we're going to talk about how to tune that one a little later. But keep in mind that if your result set is larger than that buffer, then MySQL will have to chunk the result and save each chunk to disk for final merge sort operation. Then there's another extra clause called using temporary. And of course, that is telling us, hey, a temporary table was required to kind of stage the result in order to generate the final result set. That's, using temporary is common when you have sort and group by operations, where again MySQL needs like a staging area to save the temporary result set in order to perform that last group or sort operation. Again, there's another server configuration that's relevant in this case, which is like how big are in-memory temporary tables. If these temporary tables are not large enough, then MySQL will have to spill some of the data on disk, or it will have to move, sorry, the entire table to disk, uh, uh, because again the buffer is not large enough. So also another variable that that ties to this to this extra information. And another interesting clause is the using join buffer, and this one is it's interesting because it's telling you that basically the join was not very efficient, or that for some reason um, indexes were not present for to efficiently join the data. Um, Once you see join buffer, you're going to see three different strategies, or three different join strategies that are using in combination with the buffer. One is block nested loop, the other one is batch key access, and in MySQL 8018, the hash join was introduced. And you will often see hash join being used when you are performing, again, joins using columns that don't have indexes. I mean, none of the columns involved in the join have indexes. So in that case, MySQL will resort to hash join. So aside from explain, I wanted to talk about these three tools that will help you with the execution plan analysis. The first one is the optimizer trace. I think this is a great tool if you are looking to understand a bit more how the optimization and transformation process works when a query is executed. Um, so this output will show you uh, a lot of details about what plans were considered, what the cost of each plan was, of course, which one was selected, and as I mentioned before, it will also show you which transformations were applied to the query predicate in order, for the optimizer to simplify or to understand better the execution. So again, it's a great one if you want to understand, why MySQL is choosing one plan over the other, because it will show you all the plans considered. Um, explain, analyze. This is something that was introduced on MySQL 8.0. Um, as opposed to the standard explain, this one will actually execute the query, and in real time it will show you, the actual execution stats, like the amount of rows and the time it took, each stage took, as opposed to the estimations. So you will easily see, how much the estimations differ from the reality. Again, interesting one, and remember, this one actually executes the statement. So be careful. It's not as safe as the explain um, statement. And the last one, again, it might be interesting to see the execution plan as a diagram or as a flow chart. And MySQL Workbench does a good job uh, showing you the plan that way. So you can use that feature, and it will represent the execution plan as a flow chart, and it will add some stats on the diagram as well. So again, it's interesting to see the execution plan in a different way. Now that we know, how to spot, potential problems on queries, or where to look when it comes to the execution plan, it's time to come up with our, fixes and improvements to see what can we do for our queries to run within, the specified threshold. Usually, the fixes and improvements, work at three different levels. The first one, of course, is the query. We need to see if there's something we can change on the query, either to, again, start using an index that's not being used, or make use of a MySQL optimization that, because of something we are doing, we are preventing the engine from applying that transformation or optimization. So see how can we how can we adjust the query text to have a better execution plan. Of course, the idea is not to change the actual purpose of the query, but to see if we can either make use of indexes or optimizations that we are currently not being used, or try to at least reduce the amount of data that the query is reading. Then we can do also work at the schema level. See what can we change at the row, table, or index level to improve query execution. That will hopefully benefit not only perhaps the query that triggered that schema review, but hopefully all queries that are reading from those tables. And at the end we have the server level. Of course, we cannot adjust the configuration around a single or a couple queries, but sometimes we can definitely improve the conditions for most queries to run better. And even if we realize, after we start doing this query analysis, if we realize that our workload have like certain patterns, patterns, then sometimes adjusting these buffers that are key to query execution could definitely improve the execution time. So again, I'm not suggesting just throw more memory into the problem, but again, in some cases it makes sense to adjust the configuration, especially when we are not able to find anything at the query or the schema level. So let's review a few alternatives we have at the query level. Of course, this is not a full list. It's just a kind of a real life list of things that can be changed in order to improve our execution time at the query text level. So for example, I have another index condition to narrow the range scan. Right, sometimes we are using an index prefix, and there's another column on the same index that can be also leverage to reduce cardinality. And sometimes adding that index, that second column to the query doesn't really change the purpose of the query. I have seen this many times. um, Replace an insub query by a join. That's another typical example of situations where you can actually you know turn that subquery into a join, and avoid forcing the server to having to first solve that subquery to then perform the join operation. There are many optimizations around the in subquery um, statements. Sometimes MySQL is smart enough to figure out, but again, if we can turn that subquery into a join, it's something more natural for the server to resolve. Functions, move functions to the values instead of the columns. That's another classic error or another classic problem where when you apply the function to the column, then that prevents the server from using the index on that column, because again, it would have to compute uh, the values for each of the index keys, and that again, that's too complex. So it will avoid using the index altogether. And as we're going to see later, that can be solved using a function-based index. Like if you can't really remove that function from the column. Union all as opposed to union. The union operation involves the duplicating data, and sometimes that's not required. So you can opt out the deduplication phase using union all. Reduce the amount of values in an in clause. I've seen, like, this is very common, and again, this is also something that ORMs unfortunately generate, is like huge statements with or huge in statements with a lot of values in it. If there's a way to narrow down that list, or kind of split it, that could also help, of course, with the query execution. Um, Again, sometimes this is not possible, but if you can avoid using a wildcard when you're using a like if you can avoid using the prefix at the beginning of the string, that will allow the optimizer, or allow the server to use the index. Like when you use a wildcard at the beginning, then the server can't really use the index, because um, yeah, there's no way to, since the first part is a wildcard, there's no way to use the key to search. Um, Again, turn a table as a query into a join. Again, that's kind of related to my comments above about the subquery and the in clause. Include partition keys on the query. Of course, when you have partition tables, you definitely need to try to have your partition key on most of your queries to take advantage of the partition pruning, which is, of course, uh, MySQL will not touch or scan any partitions that doesn't match the partition key. If you don't specify the partition key on the query, then MySQL can't use that resource. And again, related to the above, also narrow down the amount of partitions. Sometimes your query needs to access more than one. Well, see if you can you know keep narrow down the amount of partitions that need to be accessed. Um, Select star. Again, this is kind of a best practice, right? Always try to specify the columns that you are interested in, and not just a star. Uh, it's a good development practice, because again, in case columns are renamed or columns are added, then you're not moving excessive data. You're not requesting data that is no longer required, and also because you might be asking for columns that are not really needed, and sometimes uh, queries that can be solved using an index or covering index will not, because the query, the server will need to access the table anyway to retrieve the additional columns, but in some cases, they were not required. So again, select star avoided both from a coding and from a performance standpoint. Okay, so at the schema level, of course, the first item we have is we can see what indexes can be added or modified or even dropped, right? I included dropping indexes that are not being used because um, these indexes will definitely impact write operations. Indexes need to be maintained when data changes. So if they are duplicated or they are not being used, we can just get rid of them. Um, Covering indexes, this is a well-known strategy where you basically add all columns for a given query on an index to avoid accessing the table. Function-based indexes, as I mentioned before, when you can't really avoid using a function on a column, then having this type of indexes will allow the server to use them. Index and generated columns, again, these are used when you have columns that are created as a combination of other columns. Well, you can have indexes for those type of columns as well, and they could be leveraged on queries. And of course, adding additional columns to an existing index to improve cardinality, right? Sometimes uh, the index is not selective enough, and including another related column will help improving that cardinality. So additional things we could do at the schema level, of course, foreign keys. Foreign keys, in order to maintain that referential integrity, additional lookups are required when we are, updating data and deleting data. So again, foreign keys are always in the center of discussion, right? They are great for data set consistency, but at the same time they end up adding overhead. So you if your if latency is pretty critical to your applications, then you might consider removing the foreign keys. Generated columns, as I mentioned before, it's a way to be able to index a combination of two columns without actually having to materialize that column. Um, Numbers as strings that we want to avoid having to you know numbers are easier to handle than strings for the server. So if you're only storing numbers, it's make sure that you're using the right data type. Charts and mismatches. This could affect index usage, right? So if you're joining by a column, and even though the columns look the same, but they have different chart sets, that could make the server not to use an index in that case. So be careful with having different chart sets on tables that are being joined. Normalization, sometimes we are storing redundant data on the same table, and again, this is more like something that's definitely not new, and it's kind of a best practice to like move that redundant data out of the table, into like a specific lookup table, and then refer uh, to an ID on that lookup table. Um, Unique constraints also, they need to be checked and enforced with every insert and update operation. So don't overuse them, right? Okay, let's see what we can do at the server configuration level. First of all, temporary table size. If your workload is using order bys and group bys frequently, and again, there's nothing we can really do about them. You just really need those clauses. Uh, then it might be a good idea to bump these variables up a little bit, so we avoid temporary tables having to be stored on disk. Keep in mind these variables work together, and the smaller value will be enforced. So make sure you keep the values the same. The sort buffer, as I mentioned before, if it, the data to be sorted doesn't fit the buffer, it will be dumped to disk. So again, if we are doing sorting recurrently, and an index is not being used, so we are seeing that using file sort clause on the extra column of the explain plan, then again, it might be a good idea to tweak this buffer a little bit. Uh, you know, and again, we can keep an eye on the status variable sort merge passes. You know, and we should aim for keeping that the amount of passes as low as possible. Yeah, again, the joint buffer is used for not direct joint operations, I would say. So operations where you need to save like a partial join for to perform an additional operation later. So again, when you have non-trivial join operations, then and they can't be avoided, take a look at the join buffer and see if you can increase it a little bit. Um, the buffer pool size is something that is more global to the server, right? Keep an eye on the heat radio and the radio of pages served from disk versus the pages that were served from memory. And if you're seeing that ratio is not close to 100, like it's around 90 or less, then perhaps additional buffer pool might be required. The log buffer size, it's important to performance because when that log buffer is full, the server, the transactions will need to wait for the buffer to be, flushed. So yeah, that's why again it's important to keep it well tuned. And page sample, auto recall, and stats. That's something I'm gonna cover in a moment. So, but it's definitely part of things that we can change at the server configuration level. So I didn't want to wrap up this session without talking a little bit about statistics. Our execution plans are generated based on the statistics we have about tables and indexes. So again, the quality of the plan will definitely depend on the quality of the statistics we have. So I think it's worth taking a look at this topic before we wrap up. Um, each storage engine exposes its own statistics, right? And because of that, MariaDB introduced what's called engine independent statistics in version 10.0, right? They introduced these to overcome the limitation of again of statistics depending on the storage engine. So that way, with this engine independent statistics, you can have the same level of data uh, about your tables and indexes regardless of the storage engine you're using. On the other hand, the MySQL and Percona flavors allow DBAs to adjust costs for some operations, um, both at the server and the storage engine level. So you will find on the MySQL database a couple tables. One is engine costs, and the other one is server costs. And you will see there are values there that can be tweaked in order to influence the optimizer uh, and to pick a certain execution path. Also, in the past, statistics were transient. That means that they were saved in memory and they were recreated every time the server restarted. In order to achieve more predictable execution plans, persistent statistics were introduced, and that's the current default. Um, for the InnoDB storage engine, we have the sample pages and auto recall parameters that will help us, tune how many index pages we want the server to check in order to make assumptions about the data distribution. And the auto recall will tell us how much the data should change before triggering an statistics recalculation. As mentioned before, MariaDB introduced engine-independent statistics, and they use stats table variable controls when the server should use those statistics. they are also visible on the MySQL schema. And again, as also as mentioned before, these two tables uh, have costs that can be tweaked for the MySQL and Percona distributions. And once changes are made, a flush statement needs to be executed for those changes to become active. That's all for this session. Thanks a lot for listening, and I'll be in YouTube answering any questions you may have. See you.
Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Hey, hi everyone. Good morning, good afternoon, good evening to all. Today we will be discussing about some techniques to optimize MySQL server. Before that, let me first quickly introduce myself. So, I am Yunus and I am from Mumbai, India. I have been working in Percona from last 3.5 years, and I have around 15 years of experience in system and database administration. I have completed my bachelor's in computer application. I enjoy exploring new open source technologies, and I like to play cricket in my free time, and I also like to spend time with my family. And these are my two daughters, me in my picture. Mm, so the agenda about this talk is like we will try to see how we can optimize a MySQL server when we install, or even when we are already using it. We will try to learn some best possible ways to optimize it. We will try to understand how it works first, and then once we understand that, uh, we should be able to understand what all parameters can affect in what way for MySQL. So we will also discuss on the best possible ways to make the queries faster. After that, we will also try to discuss what all parameters we can tweak to MySQL, make the MySQL better in performance. We will also try to figure out how we can optimize some parameters in operating system to get most out of MySQL from the hardware resources as well. At last, we will also take a look how scaling can help us to optimize the performance too. So MySQL architecture. Let's see. So MySQL is very different from other database servers, and its architecture characteristics make it very useful for wide range of applications. MySQL is flexible enough to work in very demanding environments like web application, online transaction processing, highly available and redundant systems too. To get the most out of MySQL, it is very important to understand how MySQL functions, so we can work with it and not against it. So here is the MySQL architecture. These are the major components of MySQL architecture: application layer, SQL layer, storage layer. All are different and connected to one in another. So the MySQL architecture shows how the different components of MySQL system relate to one another. It is basically a client server system, where MySQL is a server and the connections coming to MySQL are clients. So MySQL most unusual and important feature is its storage engine architecture. It was designed with separate query processing and other server tasks from data storage and retrieval. If you need to get high performance from your MySQL server, one of the best ways to invest your time is to learn how MySQL optimizes and executes the queries. So once you understand the process, optimization is just a matter of reasoning, and then query optimization becomes a very logical process. Here is how the flow works. First, the client sends the SQL statements to the server. SQL statement is then tries to authenticate. It authenticates and then get connected to connection pool. Connection pool will try to see the query cache first if it is enabled. Server used to have query cache before MySQL 8, but it was removed before in MySQL 8 because of some performance problems. So if when the query cache is disabled, then the connection, once it gets the connection thread, it will then try server will parse the query. It will authorize the SQL statement, and result of this is parse tree. The optimizer turns the parse tree into query execution plan. The executor then takes the query plan and make a call to storage engine to get the result. And then finally, the server sends the result back to client. So each step takes time and can be a complex operation consisting of several steps. We will see one by one each layer. So the application layer consists of connection handling, parser, authentication, and security. So under connection handling, when a client connects to a server, the client gets its own thread for connection. So all queries that are executed by client is executed from that specific thread only. The thread is cached by the server, so they don't need to be created and destroyed for each new connection. So once the connection is made, um, the query cache comes in if it is enabled. The query cache was removed from MySQL 8.0 before because of some performance issue. Query cache is used actually to cache the result of a query, and then identical select queries execute faster if it fetch from memory. But in bigger environment, if you are updating the tables very frequently, then the query cache is of very less use because you invalidate the query cache as soon as you update the tables, right? So if you set the large query cache, it can cause the lock contention as well on query cache. Due to not fitting properly in the larger environment, the query cache was disabled by default in 5.6 and removed in 8.0. So when the query cache is not present, the query will directly go to the parser. MySQL parser breaks the query and into tokens and build a parse tree from them. It will build a tree, uh, divide the queries into tokens, and after the data is available in smaller elements, then parser will perform a syntax check on it. Parser uses SQL grammar to validate the query if there is any error in the grammar, or it also does the checks, for example, checking if the table exists or if the column exists. Then the preprocessor will check the privileges if it has the proper permissions or privileges to execute the query. So this is very fast process. So as soon as the parsing is done, query looks for the rewriter. If the rewriter plugin is enabled, or if the rewriter is available, then if the query matches the rewriter rule, it will um, rewrite the query if required based on rule defined. If it does not matches any rule, it will go, the parse tree becomes valid later and become ready for optimizer to turn into query execution plan. So query can be executed in many different ways and can produce the same result. For example, if there are multiple indexes, it can use one or the other index to run the query, or maybe it can use the different path as well. But MySQL Optimizer calculate cost of each path. Uh, it tries to predict the cost from different execution plans and chooses the least expensive one. So numbers are actually estimated from the table statistics. For example, number of pages per table or number of indexes, cardinality values, and the length of the rows. It is possible that optimizer will not always choose the best plan because the statistics can be incorrect if it is not updated. Table statistics can be inaccurate because storage engine does not maintain accurate statistics about number of rows in the table. So optimizer job is to choose the least expensive plan based on the table statistics. So it is very important to keep the statistics updated. MySQL simply follow the query execution plan. Executor then gives the response to the client. So the storage engine layer, there are multiple storage engines which can be implemented as a plugin, but we will be talking about InnoDB here. InnoDB is a default storage engine for MySQL and broadly used overall. It is a fully transactional and also has a very good support for high concurrency workload. It is reliable, highly, and made for high workload as well. So let's try to see how we can optimize MySQL. Here we have tried to explain some indexing, how indexing can help, how we can measure the performance, and how we can make the queries faster, just as an example. So measuring the performance is the key to MySQL database. If you can't measure, you cannot improve, right? You will be in trouble once it starts behaving bad. If you don't measure, you will not be able to know whether your system is good or not. Maybe your system has started responding slowly, but you are unaware. But once at a time when the data grows, it will start affecting you, and you will only see the problem when you are in trouble. So how does measuring help us? So when we encounter any performance problem, the first step to determine is what is causing it. We are running queries on the server and response is slow. Our aim is to make query faster. Our goal is to reduce response time, and therefore we need to understand why the server requires a certain amount of time for a query. So we need to measure where the time is being spent. We cannot reliably optimize what we cannot measure. So there is no way to measure improve performance and reliability when we don't have the necessary data. So our first step is to measure where the time is being spent. So let's see how we can measure it. So best tools available to monitor is MySQL has its own performance schema if you want to inspect internal execution of queries. It had some performance overhead in the old version, but from by MySQL version 5.6, 5.7, and 8.0, it has got better. And we don't see we can just have negligible performance degradation. It does not affect at all. So right now the performance schema is by default enabled as well. However, if we talk about monitoring metrics of database, PMM is one of the best open source tool available to monitor the database, and it has alerting feature as well now. So it monitors the health of the database infrastructure and explore new patterns in database behavior as well. So along with it, we also have a very good query analytics dashboard which help you to be up to date about the bad queries. It can give all the details about the bad queries in the query analyzer. PMM can collect data either from slow query logs or from performance schema, both. If you don't want performance schema, you can actually get the data from slow query logs as well. So let's get some overview how performance schema helps us. So it is been enabled by default. When the server starts, it sees the performance schema and attempts to initialize the performance schema. To verify successful initialization, use the statement that is given in the GIF image. Show variables like performance schema. The value of on means that the performance schema is initialized successfully and is ready for use. Value off means that some error occurred, then you will need to check the server log for more information what went wrong during initialization performance schema. The performance schema is intended to provide access to useful information and server execution while having minimal impact on server performance. So it does not, even if the initialization of performance schema will fail, the server will start. It does not have any effect. So performance schema is actually a place when it comes to information of the queries executed on the server. So it is the database that contains a few table with lot of information. One of the most often used table in performance schema is event statement summary by digest. This table contain all the queries that have been executed on the instance since it was restarted. So it contains a lot of information and you can view the details as needed by you. So here is just an example of a record in events, some statement summary by digest. Record shows the insert query as a digest text. So this is just an example, digest example of an event in event statement summary by digest. We can just walk through what fields can help us find more valuable information from this table. Since we said that there is a lot of information in performance schema, we cannot spend time on all the queries checking one by one, right? It would be good to order the queries that spend most time on the server. So the good candidate for ordering would be total time queries that has spent on the server, which is shown by some timer wait. Some timer wait is calculated by count star multiplied by average timer wait. That means that count star is number of time the query was executed on the server, and average timer wait is the average number of time the query took to execute. Um, so you can put a sort and get the results of top queries that have spent most time on the server. So digest text will normalize the query and put it in a common form to form a digest text. For example, this select sleep 40, select sleep 20 would become select sleep as a common query, as a digest text. And some log time field is the total time that is spent table spent on table waiting for locks. Our aim is to find the things that are most important depending on the situation, not looking at all the values. For example, if we have any issue related to temporary table creation, we have a good candidate fields like some created temp disk tables, some created temp tables. Um, that can help us finding whether the temporary tables are created on disk, and on disk temporary tables can cause problems. We can look at performance schema according to our needs. But do we need to find out these details manually when we have PMM that can do the same thing for us? So PMM, as discussed earlier, is one of the best tools available for analyzing queries. It is an open source free tool. PMM can use even performance schema as well as flow query log, as we discussed earlier, to generate all the details with graphing. You can either use one of them to analyze your queries. So query analyzer feature is one of the best feature in PMM with all the details that you get under performance schema. It will keep displaying you the slow queries and keeps the analyzer page updated. It also gives you a lot of information about those bad queries, like table creation and everything that is needed. Here is the view of Query Analyzer screen on PMM. It always keeps you updated to track the queries. You can sort the queries by most time spent by just clicking query count, and there are multiple fields available to sort as well, like temp table created on disk, etc. The Query Analyzer will do all the work behind to pull the information, and you can get a report in a click. So it also contains useful information about the query example, explain plan of the query either in classic or JSON format. Both are available. It will show you the structure of all the tables involved in the query. So you can just stay on the PMM screen and get most of the information that you need for the query. We will continue seeing the graphs in PMM further discussion. So if you don't have PMM and you want to get a top 10 queries, you can also use a Percona toolkit. The PT Query Digest tool is another tool to read from your slow query logs and provide you the report of top 20 queries which are bad. So you can see the GIF image, how the report from PT Query Digest passing the slow logs can be created. And it has few queries in report as it is test instance, but if there are problematic queries in slow logs, it will provide you the good data in the report along with details of each query. Uh, it provides everything that is needed for checking the query. One of the nice tools from Percona toolkit, which makes our job easier. So once you got the queries, the next step is to fix the queries if there are any issues also. So here is how the explain plan look like. So explain is the tool that will help us to optimize the query, to find out how the optimizer is trying to choose the path. Explain we will help you to find that. We will use the world database to look at simple query example just to show the index. I will not be talking more about the indexing here. Uh, but we will just try to look how index can help us to better the performance. So upper image shows the structure of city table. Lower image shows the explain plan of the query with name field in where clause. This is a simple select statement with where clause to filter to rows from the field which is not indexed. So the index is present on ID as primary index and secondary index country code. So when we try to run the explain plan on this query, it shows the following rows as shown in the image. So ID, which is identifier for select. Select type is simple. There can be other type as well depending on the statement. It can be subquery, derived table, etc. So the table is the table name for which the output refers. And then the partition shows that if the table is partition and the record matching any partition, it is null for non-partition table. So our table is not partitioned. So type, how tables are joined. All means it is a full table scan for the table mentioned, which is bad. In our case, it is all because there is no index. Possible keys, all possible keys that our query can use. So our possible keys is null because our query does not have any chance to use any of the keys present in the table. So key column is like the key which the optimizer decided to choose. If there is none, then it will show as null. Key length, it shows the length of the key that MySQL has decided to use. For example, like the key, how many, we can use the key length to find out if there is any composite index. We can get from the key length that from the composite index which columns, which index it is using, which part of index it is using from key length. Reference, show which columns or constants are compared to index named in the key column to show rows from the table. So the rows means number of rows MySQL estimates that needs to be touched. Extra is more information on the optimizer chosen path it will using where. So before looking at an example of query optimization, let's see the concept of indexing. When we talk about indexes, there are two types, clustered and non-clustered. So clustered index is an index in which table records are physically stored to match the index. It stores the data required and indexed together. So fields should be unique. It can only have one clustered index, primary key per table. It cannot have value null. If there is no primary key defined, the table tries to find the first unique index as a clustered index. So a non-clustered index are the secondary indexes created other than the primary key. Logical order does not match the physical stored order of the rows. So clustered index has the data and index together matched, and secondary index does not have. They are just a logical point that is referring to them. So how does the proper indexing helps? So let's see. Before, the simple query with name field in where clause was not using an index. So as there was no index, we created an index on the name field, and under explain plan, we can see the differences now, before and after creating the index. After creating index, the type changed to reference, key was changed to new index with the name field. You can see in the GIF image, after the alter is created, you can see the explain plan, and reference was changed to constant, filtered 100%. That means only the row required is just filtered properly. It does not have to scan more rows to get the data. This is how the indexing helps us. So there are also a composite index. Composite index are the index with multiple columns. If you are filtering queries using multiple where clause, composite index can help you too in the joins, the filtering condition. So composite index can also be used as covering index too. So order of columns in a composite index is very important. You can add up to 16 columns in composite index. Most common mistake that are made while creating the composite index are the index are created separately, and another mistake is like the order of the columns are not proper. We should choose the order by thinking how oftenly the columns will be used, so we can make most of those this index. More the cardinality of the data, it would be better to place on the left side, because more cardinality will help us to choose less number of rows in start, which reduces the number of rows when the index goes to right. So I won't be going much details for query optimization. It is very broad topic. But if you would like to learn more about indexing and query optimization, there is a very good webinar which I have posted the link on this from my friend Brad. It is very good and informative webinar on query optimization. Best practices that we can follow while writing queries is use the filters properly, use a limit for pagination and less bandwidth usage, try convert greater than or equal to operator to is equal to or not is equal to, avoid using select star, instead try to select columns that are required, split big deletes, updates into multiple smaller queries, use appropriate data types, small columns are faster. Right? Make sure primary key is present for all columns. Use same data type for join columns. Always test the query before deploying on production. This is a very important thing. Never prefix wildcard while searching, because the prefixing wildcard is like we don't know what the starting string is, and it will scan the whole table for this. Even if we are specifying the string after the wildcard, it does not matter. It is of no use. It will search for the whole table. Hmm. So let's see how we can optimize MySQL Server parameters here. Um, MySQL, when you install MySQL, the default config um, for MySQL is actually not for a production server. It is good for development server, but not for a busy production database. So it is good to start with, but when your database gets busy and grows big, you will start noticing problems. The default configuration is designed to permit a MySQL server to start on a virtual machine that has approximately 512 MB of RAM on a VM. We should review the configuration on the dedicated database server and the system that is used for production. So increase the value as per the hardware configuration you have. So before reviewing the configuration options, it is important to understand how the data flows in InnoDB. So let's try to see how the read happens in InnoDB. When a client send a read request, it always read from the buffer pool. And if the data is not present in the buffer pool, it is fetched from the table space. Okay. So from the table space, does not directly goes to the client. From table space, it goes again into the buffer pool, and from buffer pool, it is sent to the client. So buffer pool is a very important part of InnoDB. Right. So buffer pool is divided into two parts. How does least recently used algorithm? So it uses least recently. So how does it manage? So there are two parts in buffer pool: old block sublist and the new block sublist. So data is always read from the head or top of the old block whole pages. Okay. So if the data from same page is required again, it is then moved to the new blocks. Like the data will, when the first time it is fetched, it will come into the top of the old blocks pages, and then when it is required again, then it will be moved to new block. The old sublist. So at the head sublist of new pages that were accessed recently. At the tail, the sublist of old pages that were accessed less recently. Less recently means it is accessed very few times. Not few times, but only once maybe. The old sublist contains less frequently accessed pages. That means which are actually candidate for eviction. It means that if page is used once but then left unused, then it will quickly be expelled from the buffer pool again. This prevent the problems like backup from spoiling the buffer pool. When the backup runs tries to do a select in the buffer pool, and then it is still there in the old sublist, and then it will be quickly expelled if it does not get used. Okay, so this helps us. So this is how the read works from InnoDB. So let's see how the writes work. So when the write request come to InnoDB, the changes are written to first to log buffer memory. From there, it is written to redo log file in a circular fashion. Okay. So from log buffer, you can see that the writes are coming here in the log buffer. From the log buffer, it tries to flush into the redo logs. From in the redo logs, how it writes is it starts from the top of the first file, it goes to the end of the first file. Once it finishes the first file is full, then it goes to the second file, and from start, and then it will go to the end of the second file. So once this file is also full, it will again move to the first file in a circular fashion. So the changes are also written to the buffer pool and marked as dirty until they can be flushed to the table space files. Okay. So at the same time, they are also written into the buffer pool. If the double write buffer is enabled, Then the flushed pages from buffer pool will first go to double write buffer. So double write buffer actually guarantees the InnoDB crash recovery if MySQL exit in middle of page writes. So this is where the place InnoDB writes the data before flushing to table space. Although data is written twice on the disk, it is designed in such a way that it does not require twice IO overhead because the data written to double write buffer is in large sequential chunk in a single fsync. Okay. So only the file system, uh, if you want to disable double write buffer, it is only good to disable it on ZFS because the other file systems does not guarantee the atomicity. So keep double write buffer on is recommended. So let's see some more parameters that can boost the MySQL performance if once we understand them. So buffer pool. So buffer pool is where the InnoDB caches its data and indexes. Since all the requests for the data go through the buffer pool, it becomes very important part of MySQL from performance point of view. So default value is 128 M. Value is in bytes. Is it is good to set up a MySQL test instance on your laptop without draining more memory, but it is not a good value for production. We can allocate more memory on production database if you have memory on the server, like if it is a dedicated database server. We should try to fit our working data set into buffer pool to get the performance. So everything that is needed can be pulled from the memory. We should actually try to make uh, most out of the memory. Like we can assign the more value to buffer pool, so our most of the data stays in the memory, because pulling out from memory is faster than pulling out from the disk. So working data set is actually the query, the data that is needed by all the queries that are getting executed from the application. So this is just actually should be the subset of total data set, because some data set can be inactive, for example, like past events that are not accessed at all from the application. So data set is just a subset of the whole data. So we can calculate a buffer pool hit ratio by checking those status variables that are shown in the image. Buffer pool hit ratio should be as close as to 100%. In some cases it is not possible, as amount of data cannot possibly fit into the memory. So that's why the buffer pool hit ratio cannot be close to 100%. But still buffer pool hit ratio is useful, as it's allowed to monitor the effectiveness of buffer pool over time, and we can compare it to our general query statistics. If the buffer pool hit rate starts to drop with degradation in query performance, we should look at increasing buffer pool size then. You can calculate the buffer pool hit ratio in the way how it is shown in the image. You have the status variable InnoDB pages read and InnoDB buffer pool um, read requests, and you can use the formula to calculate the buffer pool hit ratio. We should try to keep the buffer pool size of around 80% of the memory on the server. Remaining of the memory can be left for operating system to perform its functions. Having said that, it is not a hard rule to assign 80%, but we actually are trying to dedicate some memory to operating system as well as the other um, usage of memory in MySQL. For example, sort buffer, key buffer. So these all things will also use memory other than InnoDB buffer pool size. They will not be used from InnoDB buffer pool, right? So we can actually again the connections as well. The connections on MySQL uses memory. So these are like other these are like not used from buffer pool. These are separately calculated memory usage. So that's why 80% and maybe 5% more you can add for MySQL again, and then 15% you can keep reserved for your operating system. So, but having said that, for example, if you have 1 TB of RAM, we can increase the percentage of memory dedicated to MySQL as a 90%, maybe 900 GB, because 100 GB is more than enough for operating system and other use of MySQL. So, But 80% is a very good value to start with, until and unless you need more memory in your notable buffer pool. So this is just a part of buffer pool graph that shows in PMM. There are more related to buffer pool. We can find more information on this page. So just thought of sharing this graph. Um, we can see that it shows what amount of buffer pool is assigned to MySQL instance, how much percentage of RAM is the size of buffer pool. It also shows that buffer pool data is 60% filled. Buffer pool miss ratio is very important one too. Again, just like the hit ratio should be as close as 100%, as we saw, but the miss ratio should be as close as zero. If it is more than zero, then it will show that it is more than, it shows us that how often the data is being pulled from the disk. If you pull the data from the disk, it will affect the performance. We will try to pull the data most from the memory instead of pulling it out from the disk. So we keep it as a zero, close to zero. If it is more, then we might need to increase our buffer pool size. So buffer pool instance is the next variable. So default value is 1. Max value can be 64. The reason for introducing this parameter was the database workload had more and more queries running in parallel and with more and more CPU per host. This led to mutex contention when accessing the data from buffer pool. For system with higher buffer pool values, dividing the buffer pool into multiple instances can improve concurrency by reducing the contention, right? As different threads reads and write to cached pages. So when the buffer pool is large, many data requests can be satisfied by retrieving from memory. We might so that's why we can encounter bottlenecks from multiple threads trying to access the buffer pool at once. So we enable multiple pools to minimize this contention. So this parameter will only be effect if the buffer pool size is 1 G. Um, if it is less than 1 GB, then it will have only one buffer pool instance, even if we have defined multiple in the configuration. So another most important variable is InnoDB log buffer size. So the redo log, it is very linked to redo log. The redo log is used during the crash recovery to correct data written by incomplete transactions, correct? So modifications that could not finish before an unexpected shutdown are replayed automatically from the redo logs during initialization and before connections are accepted on MySQL. So the redo log provides a sequential IO. That means it only has to write data as it comes without need to look up where the rows are located. Just like not in the case of table space to improve the performance. Table, when it writes to table space, it has to search for indexes where the rows are located. It has to update the indexes, everything. But in the redo log, it is not like that. It is just writing and just write the data, and once the redo log is full, it will have to flush it to the table space. So this allows transaction to keep changes in memory until the buffer is full or changes are committed. So default size of log buffer is 16 MB. If you have large transaction or high number of concurrent transaction, um, it is recommended to increase the log buffer size. So if we have small log buffer size and transaction does not fit in the log buffer, it will have to write the log to the disk before the transaction commit, and it will impact the performance, right? Because if our transaction does not fit into the log buffer, it will start writing on the disk, and our transaction can cause problems. If you have transaction that update, insert, or delete many rows, making the log buffer larger saves a lot of disk IO. So in these cases, you can increase your log buffer size. So you can see your log buffer usage from the PMM as well. If you see this graph, max log space used to nearing to your log buffer size, you can try to increase your log buffer. The redo log is used. Actually, so if you have last transaction, this graph will show you the proper data. So another parameter is InnoDB log file size. MySQL InnoDB storage engine uses a fixed size redo log space. Okay, so two variables are used to control the size: InnoDB log file size and InnoDB log files in group. So both of them have default values like 48 MB for InnoDB log file size and default value for 2 for InnoDB log files in group. You can multiply those value and get the redo log. For example, 48 MB and into 2, the default log file size is 96 MB. So it does not matter if you change InnoDB log file size or InnoDB log files in group if you want to increase, but it is good practice to keep not more files with and just increase the log file size instead of increasing InnoDB log files in group. Uh, so redo log file size is one of the most important configuration options for write intensive workload. However, when it comes with the trade-off, why it is actually um, most important configuration of write intensive workload is like when you start flushing to the redo log. Um, so the redo log, if it is small, it will become full very fast, right? So the transactions comes into the redo log, then it will, once it becomes full, it will have to flush to the table space. And flushing more to the table space will increase the disk IO, and because of that, um, the writes, when the writes are there, there will be more flush, right? So making so when when you increase the redo InnoDB log file size, your redo logs become larger and the flushing activity become less. So the larger the value, the less the checkpoint and flushing activity in buffer pool. So big redo log files cost more recovery time when system loses power or crash for any reason. Okay. There is also some when we increase the redo log file size, the system will when the crash happens, the recovery time will be little bit higher than what it was with the less InnoDB log file size. But it is getting the InnoDB log file size is important to achieve the balance between fast crash recovery and a good system performance both. We need to choose it wisely. So InnoDB log file size, PMM provide a good view to monitor InnoDB log file size if it is needs to be increased. So here PMM is providing the view of InnoDB checkpoint age. So if your max checkpoint, if your uncheckpointed bytes are actually um, almost reaching out to a max checkpoint age, then you surely need to increase your InnoDB log file size. So when the checkpoint age reaches the maximum checkpoint age, blocks are flushed synchronously. The rule of thumb is to keep 1 hour of traffic in those logs and let the checksumming performs. It works as smooth as possible. If you don't do this, InnoDB will do the synchronous flushing at the worst possible time. So that will affect the disk IO and can cause problems. So in the graph which we can see, before we had the InnoDB log file size at around 16, we were having the log file size of around 16 MB, sorry, 96 MB, and it was almost touching the max checkpoint age. But after we increased, it was way below around 1730. The transaction ran for testing the insert was same, and the later one completed quicker than the previous one, and also it was like way below the max checkpoint age. So this is how the PMM will help you to see the graphs, right? So another important configuration is max connection. So max connections is once again a very important parameter that needs to be increased on the production system. So default value of 151 is, it will only allow 151 connection on the system. If it reaches to 151, you will start getting too many connection errors. Once you reach that many connection, there is only one user, root user, admin user can log in into the system. After that, max connection is not setting that you can just increase on the fly without knowing anything. Max connection is actually a guard for your server to make sure that it should not allow the connections after it crosses that many numbers. So you need to choose this number very wisely. um, Setting the number of connection to just few thousands does not work, because if you allow the more connection on your database can use more memory, because every connection needs some memory, right? And we can calculate as a rule of thumb, like we can consider a 1 MB of memory for each connection and calculate how many connections we are allowing, and how much memory your server will be using. You can calculate along with this. Is separate than inodb buffer pool size, so don't calculate it in inodb buffer pool size. Okay? That is a different memory settings. So this is excluding inodb buffer pool size you need to calculate. So you need to make sure how much connection your application will be sending, and you need to also configure balance. So there is a very good graph again for MySQL connection. If you are using your application from quite long, you can see the graphs that how much connection your application is making, and you can set up um, the max connections according to that value. If you get logged out of connection, um, you can use one extra connection with admin user and password on localhost to log in and kill the connection. From 8014, I think we also have the option to specify admin address and admin port to provide a completely different endpoint. But if we are using Percona server for MySQL, we have the option to use extra port and extra max connection in this situation for the lower versions as well. So the next important parameter is temp table size. Temp table size is one of the variable which can affect the performance if the temporary tables are created on the disk. Default temp table size is 16 M. It only applies for the temp tables that are created in memory. It does not apply for the memory tables that are created by a user. Okay, so it is recommended to set globally the lower value and increase the value in session. This is a dynamic variable, session variable as well. So if it is needed by any query that you think that the temporary tables will be created, you can just increase the temporary table size for that session and then create the temp tables. If the temporary tables when the temporary tables is created on disk, is like if the temporary table exceeds the temp table size, it will move the temp table to disk and can affect drastically in performance. To check the status if the tables were created on disk, we have two variables, status variables, which we can check: created temp disk tables and created temps tables. We can compare that how many tables were created temporary and how many disk tables were created using the status variables. And the same can be found from the PMM graph as well. PMM also shows a very good view. If the tables were created on disk, at what time we should either fix the queries that are created in disk temporary tables if they are bad, or if needed, increase the temp table size. So another variable, very important one, is open files limit. Even though the default value says that it is 5000, if you are installing if you are using a Linux operating system, and the file limits are actually defined on the OS as well. So even though if you have file limits as 5000 as default, but the OS limits only 1024 um, soft and hard file limit for each user. So until you can check that by ulimit -n by logging in from that particular user from which the MySQL is running. And if you think that it is 1024, then you will have to increase the value for soft and hard limits to use the more number of open file limits. So until you increase it in operating system first, it will not allow the open file limits to increase. So it is very important parameter that you tweak from the operating system before. So InnoDB flush log at TRX commit. This is actually by default one, and it should be one by default, and not needed to change. But still, this I have mentioned just to understand, because it also affects the performance. Since it default value is one, it is ACID compliance setting, and we should keep it as one until and unless it is you understand what the other values are can affect. So the default setting of 1 is required for full ACID compliance. Logs are written and flushed to disk at each transaction commit. So every transaction commit will be flushed to disk. So with a setting of 0, logs are written and flushed to disk once per second. So so logs will be written and flushed to disk once per second. Transaction for which logs have not been flushed can be lost in the crash. So with a setting of 2, logs are written after each transaction commit and flushed to disk once per second. So transaction for which logs have not been flushed can be lost again in this crash, in if the crash happens. So these are some important settings that we can use to tweak the performance. Monitoring using PMM would help us to understand more about your metrics and tweak the settings as well. So some OS optimization tips here. We will quickly overview what we can do in OS to optimize. So operating system by default allows 1024. So it is important this what we discussed in the open files limit by installing. So MySQL has enough file descriptors. We need to increase this value. Keep the swapping to minimum value of 1. A lower value of swappiness will make kernel to avoid swapping whenever possible, while higher value will always try to use swap more aggressively. By default, the swappiness is set to 60. We will try to change it to a lower value, that is 1, so that it avoids swappiness. So install the Gemalog library. When you install the new server, try to use it with the Gemalog library for Percona server, along with Percona server with a transparent huge pages disabled. This is a less memory. There is less memory fragmentation and more efficient resource management. There is a very good blog by Vinny on this. You can refer more there. I have provided the link. Uh, you can add some more best practices while mounting the file systems. Have a different disk for data and logs so that the disk IO gets distributed while writing data and logs both, binary logs and data. So use proper mount option like no a time and no dir a time, because we don't need to have updated time for reading the directories and files, right? So we can just remove that overhead, and so that it does not spend time to gather those times at all for our mount points. So we can add these both mount options on all our disk, like data for data disk as well as log disk while mounting. So this will help us to um, make the operating system more optimized. So the scaling the reads. So scaling will help you distribute the read traffic across the nodes. We can set up the multiple node replication. We can serve the read request, route all the writes to the master, and route all the reads to replicas. Master will have reduced load since the reads will be distributed across the replicas. Replica can also be used as a backup server too. Instead of running a backup on master directly, which is not recommended, we can run backup on replica. This will again reduce load and locks on the master that backups can create, and will let the master do its only writing job alone. So the best scaling load balancer is Proxy SQL is one of the best tool. Um, we already had a talk in Percona Live 2022 to scale the environment with Proxy SQL along with the failover. I will be writing blogs very soon for that, um, for using a Proxy SQL with high availability. We'll let you know. Keep watching the Percona blogs for it. So the conclusion is here: monitor for improving the performance. Without monitoring, um, it is very difficult to optimize and improve the performance. PMM is a best open source tool uh, to monitor the database performance. And whenever you are changing the configuration, try to do one configuration change at a time and then monitor how it affects. Graphs will help you. The PMM graphs will help you to monitor the change, how it affects, whether before the change how the performance was there, and after the change how the performance is. You can compare both of them, and if you are benefiting it from it, you can keep the change. Understand the configuration before making changes. Test it on development and state server before you put it on production. This is very important rule. Without testing, don't touch the production server if it is not hampering you. So the test on the test and production data is very important. Yeah, that's it. If you have any questions, just let me know. Thank you very much for staying with me. Thank you. Have a nice day. Bye.
Hi everyone. Welcome to my presentation, Database Reliability Engineering for MySQL. Um, my name is Matthias Krauls. I'm presenting to you from Belgium. Currently, I'm a principal consultant in Python's OSDB group. I have a bachelor's degree in computer science. I've been using and administrating Linux machines for as long as I can remember, over 25 years now. And I've been involved with MySQL for over 10 years. As a principal consultant, I'm mostly focused on MySQL at Python, but we also support other technologies. This is something about the company and all the problems that we see in our customer base, and then these are the places where we can help our customers. As you can see, we do consulting, managed services, we do migrations, and also cloud solutions, as well as on-premise, as basically anything that the customer needs. When we're talking about database reliability engineering, I see four main focus areas. The first one is availability, and preferably high availability, and we'll talk about the difference between both of them. Service discovery, knowing where your services are. Observability, knowing what's going on within your databases, and then when disaster strikes, how can you recover, and can you get back up to running situation. So yeah, let's get started with the first one. So high availability. So when you look at this very average car, you see that this car has 4 wheels. Well, you can only see 3, but I can guarantee you that there's a 4th one. So what this car needs to operate, to work, is 4 wheels. If you lose 1 wheel, the car is not working, so it's not available. So having 4 wheels for your car is not high availability. When we're talking about high availability, we can keep the same comparison and talk about the wheels of a car. And in this case, we're talking about the bolts holding the wheel in place on the car. And in this picture, there's 5 of those bolts. And if you lose one, it doesn't mean that your car won't drive anymore. It doesn't mean that your car is not available anymore. So those 5 different bolts, they are ensuring high availability. So if you lose one, you can still operate. There's no need to no immediate need to stop everything and to fix it. Like if you lose a wheel, then you can't ride anymore. But if you lose a bolt, then you can still ride. You can still drive. You might want to go see a mechanic to figure out why you lose a bolt. Maybe it wasn't tightened enough on the last maintenance, and so then it's a human error. Or maybe there's something structural wrong on the car that the bolts are loosening, and so you need to see a mechanic to figure out why and to try and fix it. But this is the difference between availability and high availability. If we now go back to the database, because we're here to talk about MySQL, when do we consider MySQL available? So in most cases, you will need just one server to write transactions, which is your primary, or used to be called the master. And then you need at least one server to read transactions from. In the worst case, you can use both the same server for both operations. But in many cases, when you have a very large scale website or application, you're gonna need more than one read server, and this is what we need to have availability for MySQL. So high availability in that case means that we make sure that we can keep the database available even when a server fails. So this is your general topology. You have one primary, one writer server on top. taking all the writes, and then you have a bunch of read servers on the bottom where you can do read scale out for your applications. And in this case, the master is a single point of failure. So if your writer server fails, no more writes can happen to the database, and your application will be down, or at least have some kind of degradation, because you won't be able to write. Imagine a service like Twitter. You can probably still read all the existing tweets, but you cannot send a new one. So that would be a problem for many people. So in order to prevent this single server to be a single point of failure, we will introduce a topology management tool to handle these kinds of failures. And so the tool that we will introduce is called Orchestrator. And Orchestrator is a high availability and replication management tool. You can use it for all kinds of purposes in your MySQL environment. If you connect it, you can use it for discovery. And so what this will do is, if you give Orchestrator the coordinates of one of the servers, it will start using the regular DBA commands like show slave host, show process list, show slave status to try and connect to the other servers in the topology. And that way it will discover the entire topology by just feeding it one single server. One requirement is it needs to be able to connect. If it can't connect, it can't run the commands I'm listing here. So you need your automation when you spin up a new server to create the Orchestrator topology user, so Orchestrator can connect to the database to figure out where the topology fits. And then the very nice and very useful feature that Orchestrator has is the visualization, the web UI. So when it discovers all those servers, it will present them to you in a very nicely formed web UI, which you see an example from here. This is from the Orchestrator manual. And as you can see, there's different colors in the servers. You have the orange, green, blue, red ones. So these designate different data centers. So this topology is an anonymized topology. There's no specifics about these servers. Like you can see that they're 5.7, but not the minor version. You cannot see their host name. You can see their replication delay, but nothing more than that. So that's also a feature of Orchestrator. If you want to create screenshots of your topology, you can anonymize them to make sure that you don't expose too much information about your environment. And then the third and probably most useful feature of Orchestrator is the ability to refactor. So what we understand by refactoring the topology is making changes, like pointing a replica to a new master, or promote a new server to become the new master or the new primary, or do things like start stop a replica, do some maintenance on the binary logs. All of those things are things that Orchestrator knows about and that it can help you with. So there's a command line tool that you can use. There's an API where you can script a lot of things, or there's the web UI where you can do drag and drop. So you can basically drag one server to another location in the topology, and Orchestrator should be able to figure out how to reconfigure replications so it can handle the change. There's some prerequisites for that, obviously, but in general, Orchestrator can do that to almost any topology running MySQL. And then all of these things, they are extremely nice, but if if your master goes down or your primary goes down in the middle of the night, and you get paged to go log into Orchestrator and do the drag and drop, or to run a script, to do the promotion, you're not going to be happy. What Orchestrator can also do is it can automate the recovery. So you don't have to get up, so it can automatically figure out, hey, the master is down, I need to create a new master and recover the topology. To do this, first of all, the detection of the failure is a requirement. And so if you think your typical monitoring tools like Nagios, Zynga, those kind of tools, they will send probes. So they probe the master or the primary, and what do when they detect a failure? So imagine your monitoring tool tries to connect to your primary, and it cannot. What do? Do you take immediate action? It might be like there's a network failure between the monitoring tool and the database. Will you retry maybe to see if there's actually a problem, or if the monitoring was having like a temporary failure, or and if you retry, how many times will you retry? So all of those things are items you have to think about when setting up automation. The advantage that Orchestrator has, it's connected to every server in the topology, and it can gather information from all of those instances. So if it detects a problem on the primary, it will check with all the replicas of that primary, like, hey, can you still see that primary? If you can see the primary, then there's no problem. Then I have a detection issue, and I won't take any action. But if all the other replicas are saying, hey, we can't talk to our primary, we don't get any binary log events anymore, then Orchestrator can be fairly certain that there's a problem, an actual problem with the primary, and it can use that knowledge to make decisions and to do a promotion on the first detection. And this is what Orchestrator calls the holistic approach to monitoring, instead of an individual server by server approach. And so back to our example, so we had the situation on the left where our writer went down, and so what Orchestrator will do is it will take one of those readers, make it a new writer, reattach all the remaining readers to the new writer server, and take the old writer out of the cluster. So it will put that server aside. Something went wrong with that server. It might be as simple as like a network glitch, and at that point you can say, okay, this server is healthy and we can put it back in topology, but it needs a human to look at it, to investigate what happened. And to prevent for all reader servers from being promoted to master, and every time the master being put aside, there is an anti-flapping mechanism built in Orchestrator. By default, it will not make a new promotion within the hour. So what you might want to do is send some kind of alert that someone needs to check on what happened to that old writer. Make sure that it gets back into the pool of available servers, and figure out and acknowledge that everything is fine on the new topology. So to do this, if you run a single Orchestrator node, obviously your Orchestrator will be the single point of failure. So since Orchestrator 3.x, there's an implementation of the Raft consensus protocol in Orchestrator, which allows Orchestrator to be set up in an HA way. Well, you could set up Orchestrator as an HA system before, but then you needed like HA on the database side, and Orchestrator cannot manage its own backend database because it needs that to be functional. So if that database would have gone down, then Orchestrator would be down. So what we used to do before Orchestrator Raft was like set up a synchronous replication background, like, or virtually synchronous, like Galera or these days InnoDB cluster, which is still available. But if you use the Raft protocol, then you can you can drop that replication component from the database on the database layer, and you can even use SQLite if you have a small scale implementation. You can use SQLite as the orchestrator backend. So you don't have to manage any other database server technology for Orchestrator itself. So Raft will do leader election and distribution of the data as mentioned, and in order to have an HA setup you need at least 3 nodes. If you have 1 node you never have high availability. If 1 node goes down there's not another one to take over, so never HA. If you have only 2, then they can start, if they lose connectivity to each other, they can start fighting which one is the active part. And so you need a majority vote, so you need 50% plus 1, so you need at least 3 nodes for a high availability. So if two nodes lose connectivity, that one node will say, hey, I'm a minority, so I will be I will decommission myself for now until I can rejoin the cluster. While the other part can still be fully functional and operational. So this is what it looks like then. Before, with the synchronous replication backend, you had the replication of the data on the database layer, and there was no communication between the nodes. If every node was connected to the clusters, which also had some implications, while in the Raft version you see that the communication is happening between the application nodes. There's one leader node taking making the calls to the on the servers, and the other 2 are passive. They're monitoring, but they're following the lead of the leader node, and there's no more replication between the different backend databases. So that brings us to the next section, and that concludes the part of high availability. So brings us to service discovery. So service discovery is the ability for your application to know where the writer server is, where the reader server are, where the reader servers are, and there's several options for this. I've known installations where if the master changed, there was a deploy required to deploy the new configuration file, and then the application would start writing to the new server. This works, but this is not the most convenient way, because it needs someone to trigger that deploy or read it automatically, or the other option is to have a DNS change. In that case, you're relying on an external system. DNS is something that's probably not managed by the database team. And there's a famous Belgian blog that says everything is a freaking DNS problem. So I'm not a big fan of DNS. It's useful, but to rely on, I'm not a big fan. Floating or virtual IPs, they're also an option. In many cases, this will mean that your virtual IP is only available in a single data center, or you have to route your IP addresses to multiple data centers and then make sure that it's bound to the right one. This is a problem probably when you have a data center issue and you need to fail over to a different data center. Then virtual IPs are much more troublesome to migrate. Or the final option, and this is what we will be discussing further, is to use a proxy server, something to sit in the middle between the database and the application. And in this case, we'll be talking about Proxy SQL. Proxy SQL is a layer 7 application proxy. It's layer 7 because it's not just network throughput or not network relaying like something like HA proxy. What Proxy SQL does, it accepts the client connection, and then based on its configuration, it will send traffic to MySQL servers wherever it's configured to send it to. So it's intelligent. It can be used for multiple databases, multiple clusters. It's built on the MySQL protocol, so it can understand the traffic that passes through it, and it can do things like splitting reads from writes. It also understands the database topology underneath, so it knows whether instances are up or down, whether replication is fine, whether there's replication delay. It can even do something like GTID consistent reads, so it can make sure that the connection is only sent to a replica whenever the GTID it's requiring to be there is actually applied there. So it's very knowledgeable about the MySQL topology, and it can do very intelligent routing, and basically it protects the application from the complexity of the database technology. So from application from the application side, what it sees one server where it can connect to, and it sends a query and it gets a result. But underneath that one server, there might be tens or hundreds of MySQL servers serving the traffic. So it's a very convenient way to protect the application from that kind of complexity. To start, some terminology. So in Proxy SQL, we speak about host groups, which is basically a group of backend servers where queries will be sent to. Very important to know is if you send queries to a specific host group, the query will be sent to only one server within the same group. It will not be sent to all the servers in the group, just to one. This is to load balance between multiple servers. Query rules are like the core functionality for Proxy SQL. That this is what defines where a certain query or query type or a query for a certain user needs to be sent to. So that is where you define how the traffic will flow through your proxy. And then MySQL users and servers, these are items that the proxy needs to know where to send traffic to. So the server configuration is actually the list of MySQL servers that is available in a certain host group. And then the users are also required because the proxy will connect, the application will connect into the proxy, so it needs to authenticate to the proxy, so the proxy needs to know the users and the passwords in order to validate those credentials. And then from there on, depending on the user or the type of query or the query text or the address or the port you're connecting to, traffic is sent to the right backend server by evaluating the query rules. And then the basic design for Proxy SQL is very simple. You have your application servers connected to your proxy, and then the proxy connects to the database on the backend. And then I see people think like, hey Matthias, but now you have a single point of failure on your proxy. Correct. But this green Proxy SQL block can be multiple proxy servers, and you can basically load balance them using like a general stateless HTTP load balancer or something similar, or TCP load balancer in this case mostly, because the proxy can be clustered to share configuration. So you have multiple proxies that will distribute the configuration among each other, and then the application can basically choose which of the proxies they use, because they will all have the same configuration, and they will send the read and the write traffic to the same backend groups. Another approach is this, where you put the proxy SQL instance on the application server. So basically your application connects to localhost, and the proxy then again sends traffic to the right backend group. This works very fine also with the clustering of the proxy. In many cases, what is being done, if you have a lot of proxies, a lot of application servers, is you make a combination of both of them. You basically put the proxy SQL servers as some kind of satellite servers on the application side, and you put in the middle, you put a layer of proxy servers which do your core routing. So basically your satellite servers, they will send traffic to your core servers, and your core servers will send traffic to your database backends. That's usually the most most high available way to set up proxy SQL without the need of any additional load balancing applications or something. So that really helps. That brings us to the observability part of this presentation. So what is observability? So the first thing in observability is you need to know if your systems currently are having an issue. So you want to be alerted for problems. Like if your disk is running out of space, you want to know about this. There's many ways to alert. You can use a pager system, you can use an IM system or email. Depending on how reliable your IM or your email is, you can be satisfied with the performance of that, or you can have some kind of pager system like Opsgenie or PagerDuty or something like that to send you alerts on your phone, so you know when there's an issue. And then the other part of observability is when you need to troubleshoot performance, or when you're diagnosing an issue. You want to have some kind of graphical interface where you can have dashboards with metrics, so you can compare against the past situation, like, hey, my database is suddenly going slow. What's different in the workload against last week? So last week everything was fine, and now everything is slow. So how can we see what's ongoing? So that's what observability is about. And what we typically use when our customers don't have a good solution for this is Percona's monitoring and management tool called PMM. This is a all-in-one solution for observability, and it's mostly focused for databases. It's free and open source. It consists out of, I have a slide for that, out of several open source components. And it's an out-of-the-box solution for monitoring MySQL, Postgres, Mongo, Proxy SQL, Linux servers. It will be able to be your full monitoring and alerting stack when you configure it well. The caveat that I always tell to our customers is that this is a single server, so it's a single point of failure. There's currently no real good solution to make PMM high available. But in general, it's not mission critical for your application. So it's not if your observability stack is down that your applications will be down. It's gonna be important to not have it down and to keep it running, but it's so you can know what's going on, but it's not gonna be of that disaster kind that everything will be down, your revenue will be stopped. So that's generally not the case. Um, PMM is available as a Docker container, as a virtual machine image, or as an AWS AMI. So whenever the easiest installation way is to use the Docker container. So you basically install Docker on your favorite OS, and then you do Docker pull PMM server and Docker run PMM server, and you'll be up and running. The VM image also works but you'll need the virtualization team to approve that image to be loaded. And in AWS you can always use the AMI, which is a convenient way to spin up an EC2 instance for PMM. So these are the components. In general, you have a PMM server component, which is what we've been talking about so far. And then you have a PMM client, which basically runs in general on your database server. So this client has two tools to configure PMM admin and PMM agent. PMM admin is the tool that you use to write configuration into the server, and the PMM agent is the tool that ensures communication between all the components, and that will make sure that the right exporters are being started. So exporters are things that collect the metrics from your system. You have the most basic one is the node exporter, which is basically exporting information about your system, your OS. You have the MySQL D exporter, MongoDB exporter, Postgres exporter, ProxySQL exporter, and then the RDS exporter. If you want to monitor RDS, the RDS exporter then uses CloudWatch and enhanced monitoring in CloudWatch to pull system level metrics from your RDS, because you cannot install the PM client on the RDS machine because you don't have shell access. So in this case you need to install it on a different machine, which can be the PMM server but doesn't have to be the PMM server. But in many cases this is how it's done, to install the exporters or the client then on the server, to be able to collect metrics from the managed service database. On the PMM server itself, you have a big component called Victoria Metrics, which is a drop-in replacement for Prometheus. The difference between Prometheus and Victoria Metrics is mostly that Victoria Metrics supports push and pull model. So Prometheus only supports pull model, so it pulls metrics from the database server. So the monitoring server needs to be able to connect into the database server to pull metrics out. And in many cases, this connectivity into the database server is considered to be like a security hole, because you don't want anything to connect into your database. You want things to be pushed out from there. So that is why this is what I believe that made Percona switch from Prometheus to Victoria Metrics. And then you have the PMM Manage D daemon, which is the management tool that configures all the systems that are being monitored, and it uses a Postgres backend to store all of that data. On the other hand, you have the query analytics part of PMM, which connects to the database using either using a slow query log file or using the performance schema if it's enabled. And the query analytics are not stored in Victoria Metrics because Victoria Metrics is mostly a time series database. The query analytics are stored in ClickHouse, which is a column store database, which is very good for analytical workflows like finding aggregates and finding like the bad queries that consume the most time. You can use ClickHouse, and then there's a little query analytics app that is running in Grafana on the PMM server, that you can use then to explore the data stored in ClickHouse. And then Grafana is the tool that mostly exposes the metrics and the dashboards. So you have some screenshots here. The PMM login screen, something about the operating system here, like this is overall CPU utilization. This is a MySQL summary with connections, supported connections, client thread activity, all those kinds of things. And then here you have a screenshot of the query analytics, so you can see all the queries that are running. You can filter on environment, on cluster, on database name. So it's a very useful and powerful tool to know what's going on in your system and to start diagnosing issues. In the latest versions, there's also an alerting option. It's a bit out of scope for this session, but know that in the later versions of PMM, you can also use it to set up alerting, and so you based on the metrics that it collects, it can send you alerts. So, but this is out of scope for this session. So. And then the final part of database reliability engineering is disaster recovery. And disaster recovery is mostly what do you do when a catastrophic event or a human error hit your database. And there's two major factors in disaster recovery, and they're called RTO and RPO. The RPO is the point in time where you restore your service to. So in the in the graph here on the bottom, you see this is the time when disaster hits, and so the RPO is the time you need to go back to get to a point in time where you can have a consistent restore of all your data. And so the loss, the amount of data lost is the RPO. So this is the amount of data you can lose in the event of a catastrophic event or a human error happening. And then the RTO is the recovery time object. It's the time that you can be down before you can restore your service. And typically, if you want to have less downtime, you might lose more data because you basically restore an older backup, and you'll go back to that point in time, or you promote a delayed replica to become the new primary, and you start using the data as it was on that delayed replica. But mostly we try to limit the amount of data we lose, and we get a little more downtime to get to a more consistent, more reliable way for disaster recovery. And so RTO, the fastest way to get to a stable situation again is with disk snapshots. So if you want to make consistent snapshot of your data, you need to stop MySQL cleanly and then make a snapshot of the disk, or you run flush tables with read log and you freeze the file system for a moment. All of these operations, all of these options, they are invasive to MySQL. If you stop MySQL, it cannot serve traffic, so you need to run these on a special replica. But this is the fastest way to get a consistent copy of the data, and from that snapshot you can immediately spin up a new server and be going with a consistent data set. Another way to get to make a backup of MySQL is Percona Extra Backup. This is a way to do online non-blocking backups for InnoDB. InnoDB is important here because it relies on the MVCC options that InnoDB offers to to create a backup. So if you want to make a backup of my ISAM table, it doesn't have those features. So in order to make a consistent backup of my ISAM, you need to block all the traffic and make the backup of my ISAM, and then you can release the database again. So it for my ISAM per extra backup is still blocking, but the recommendation is to use InnoDB for almost all workflows, so that should not be a problem. It can do full and incremental backups. It's what we call a physical backup. It's just like a snapshot option. It takes a copy of the data on disk, but it takes a bit longer than a snapshot. Snapshot typically runs within seconds, while extra backup depends on the size of the database to run. And very important is, if you want to use extra backup, make sure that your extra backup and your MySQL version are in sync, because there was a problem a while ago where there was a change in the redo log format of MySQL in one release to the other, and all the backups started failing. So important is, before you do your MySQL upgrades, make sure that you have a working extra backup version before upgrading. So then point-in-time recovery. This is a way to reduce your RPO, your data loss, to 0. If your binary logs are backed up and available next to your general backups like snapshot or extra backup or whatever backup method you use, you can reduce your RPO to 0. Obviously, doing that takes time, so the RTO will never be 0 in this case. Well, RTO will never be 0, but it will be increased if you want to do point-in-time recovery. And in order to be able to do that, is you need to live stream your binary logs to a backup location. So when disaster hits, you can still have access to the binary logs, and you can figure out from the binary logs the exact point in time where the catastrophic event or the human error or whatever happened, and you can replay the bin logs, the binary logs, until that exact point in time, so you don't lose any data from your event. But to do that, obviously that takes time. So, conclusion. In order to have high availability and in order to have database reliability, MySQL replication is required. If you have a single server without replication, you can never achieve high availability. You can never achieve database reliability. That's a no-brainer. Orchestrator is a tool that can help you to automate your writer availability. Orchestrator will not help you for reader availability. Reader availability you need to solve by scaling. You need to have some spare servers available that can be used during an outage of one of the servers. If a reader server fails, that should not affect your database availability. That should be absorbed by the other servers in the topology. If a writer server fails, Orchestrator can help to promote a new writer server, but that takes away one of the reader servers. So you need to be able to deal with those kind of events. Proxy SQL can really help with service discovery, especially in the mixed mode where you have a core proxy and you have the satellite proxies on the application servers. It will be very easy for your application servers to figure out where the database is, and the proxy clustering will make sure that all these nodes are in sync and can be used for talking to the right database. PMM, if you don't have any monitoring tools for your databases, it's that easy to install. It's very user friendly. So I highly recommend, if you don't have anything good, or if you're not certain about what you currently have for your metrics and monitoring, I highly recommend to install PMM. to expose the environment metrics, to set up some alerting, and to be able to troubleshoot performance when it happens. And then obviously when disaster strikes, backups are always important. Make sure to make backups, make sure to test backups, because otherwise you'll shoot yourself in the foot. And that's all I have for today. So if you have any questions, feel free to ask through the channels that are available. I will be online to answer some of the questions. If you do not have any questions at this time, but if you want to reach out to me, here's my email and my Twitter. So you can always feel free to contact me if you have any questions. So and that's it. So thank you for watching, and until next time.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Please welcome to the stage with Open UK, Amanda Brock.
So, good morning, Austin. I guess this room knows a lot about open source, and you all know that we're all about community, we're all about collaboration, and we're all about conference. And how good is it to be back in the room together today? So I want to thank Percona for bringing me to the world's biggest database conference in open source. And I want to thank all of you for making the effort to be in this room today, because I know it's been a tough few years and it's hard to get everybody back together, but I think it's brilliant for us, so thank you very much. And I guess you're probably wondering what a nice girl like me is doing in a space like open source. Well, about 14 years ago, I worked for a company called Canonical, who some of you may know. And we were the commercial sponsor of the open source operating system, Ubuntu. Back then, we were the cool kids on the block, or at least we thought so. And I worked there for 5 years. I'm an ex-lawyer. I spent 25 years as a lawyer, and 5 of them in Canonical. And there was a bit of an accident happen when I joined Canonical. I was meant to come in as a corporate tech lawyer and to build out this legal team. And what actually happened was I fell passionately in love with open source, and that was just never on the agenda. So since then, I've worked in a number of different roles, and I do a lot of pro bono work. I sit in a number of advisory boards. I chaired one for the UN, Tech for Good, and in particular open source in that space is a big passion of mine. And this year, I stood for and was elected as a member of the Open Source Initiatives Board. And it's quite a big thing to take on, and I've taken it on because I thoroughly believe in some of what Peter was saying about open source. And unfortunately, the OSI doesn't own the trademark in open source, but open source has a clear meaning, and I'm going to talk to you a bit about what that is today, and what is open source and what isn't. I am the editor of a book being published in September. Now, the great thing about the book is it has 20-odd authors. It will bring lots and lots of skills and resources and information about open source to everybody, and it will be really expensive. But it will also be open access. And that open access means that that information, those skills from all these lawyers and policy people all over the world, governance people, people who understand how to build community, that will all be shared for free, which I'm really pleased about. And I can promise you, it is the only time you will see my name on the front of a book that I've edited. I will never be doing that again. I also speak a lot, and I do a lot of this traveling around talking to people about open source. And as we started the Roaring Twenties, I was quite excited because I had 20 keynotes lined up for 2020, and I did 0. They were all digital. It was heartbreaking. So for me, the year got off to a great start as we started to look at what was happening in open source, but it didn't quite work out the way I expected. And I suspect that's the last couple of years have been the same for all of you. And in Europe, and I saw this morning, to my surprise, the bulk of people being from Europe, but I guess they're logged in early, they started a digital decade. Now, I'm guessing that, like me, you probably think the digital decade was the last one. But this digital transformation that's happening at pace has now hit the point where every nation state, every government is looking at the infrastructure it has for its citizens being built on software, and that software is inevitably open source. So all of the services traditionally supplied bricks and mortar are now being digitalized. And what we're seeing there is the rise of open source, of course, because everything infrastructure-wise is being built on it. And there is some really interesting work coming out of the UK looking at government as database and saying that government is as good as the database it runs. Now, I don't normally read from slides, and I don't normally have many words on my slides, but this, I think, was really important. And this is the EU President, Ursula von der Leyen, writing to Margaret Vestager when she appointed her in 2019. Now, Vestager had been the competition, the antitrust commissioner in Europe for nearly a decade, and there are few people who understand the money in tech more than that lady does. And in this appointment, von der Leyen says to her, the changes in digital technologies and geopolitics are already having a profound effect on the lives of Europeans. We're witnessing major shifts all the way from global power structures to local politics. What we do now will determine what kind of world our children live in, and will define Europe's place in the world, creating a Europe fit for the digital age. Now, you can swap that. You can stick US in there, I can stick UK in there, we can stick Asia in there. You can pretty much do what you want with it, but it's true for all of us. What we do now is going to affect the future for our children. And the next thing that we did in the UK was we Brexited. For anyone who doesn't know what that means, it means we exited the EU. And this picture was taken at FOSDEM, the last conference that I went to face, and it was taken at FOSDEM 2020, and it's outside the Commission at midnight on the 31st, or it's actually 11:59, on the 31st of January. And what happened next was the Commission put the lights out. And I don't know if they put the lights out every night at midnight or if they were just making a point to the Brits from FOSDEM gathered outside, but we were out. And it's important because it started a lot of thinking about what this meant digitally. And we see Europe starting to talk about digital and data sovereignty, about bringing data home, looking at how it balances its own ecosystem of tech supply chain, how it balances citizen data being private and protected with the ability to make money out of data. And then, of course, along came the pandemic. And this is the little-known Scottish variant, which is actually easier because you can hear it coming. A laugh about the pandemic, something that doesn't happen every day. There's not a lot to laugh about. It's been a rough couple of years. And in some ways, it's been good for open source, but I'll come back to that later. So as that was happening, we saw digitalization for anybody who was sort of reluctant, as a reluctant technologist, happen at pace. And we saw Europe in particular really publicly, really openly redefine its boundaries. And we saw this case Schrems 2, where the arrangement between the US and Europe for the shift of data, the Privacy Shield, was set aside in a court case. And we also saw a bunch of legislation that I won't go into in detail, but which was focusing on big tech, which was focusing on how they brought the digital structure back to being European. And one way that's been done is through something called Gaia X. And talking to a couple of people, I don't think the US is quite as familiar with it. And it's a data infrastructure for Europe. It's a digital and data sovereign infrastructure. And it's built on open source, and a lot of it is going to be about open data. And as you start with that sovereignty piece, what's particularly interesting is that you see Asian companies and the big US tech companies all being part of it. We were interested in Open UK. I stuck my neck out, and we've been a day one member. Because part of what open source is about is global collaboration. And as we Brexited, we had some difficult times with some of our European colleagues, and I had to remind them that it's not local source, it's open source, and it's global. So we've been part of this from the beginning. And in Europe, you don't just see this interaction with the UK or with the US, you also see it with China and Asia. But it's not just Europe. Then you start to see this geopolitical shift in the States, and the States and China, and even the UK and China. And it spreads from being nation states into citizen activism. And we see Black Lives Matter, and we see youth action at COP26. Open UK had a big event at COP26, and I'll talk to you more as we go on about the place of open source and sustainability, and I mean ecological and sustainable development goals type sustainability. But again, youth action. And then a war. I mean, what kind of couple of years have we had? And what's that done to open source? So depending on whose reports you look at, it's going to tell you that between 58 and 98% of any software stack is open source. But that really depends on how you define what open source is and how you understand it. Now, if I was to ask everybody in this room to start to define open source, I could probably put you in the four corners, maybe more, with different definitions. And your definition is very much going to depend on your experience, your personal experience of open source. Peter talked about foundations. If you've come through that route with the big companies collaborating, for you, that's probably open source. If you've come up a community route, you probably think it's that. One thing I suspect we'll get agreement on is that it's software that is shared in the open, that follows the open source definition and has an OSI-approved license. And even if any of you in the room don't agree with that, if you look across governments, if you look across the public sectors as they're evolving, you'll see that's what government is looking for. Now, there's a problem with that. It's fine as a basic definition, and it's good if we're measuring against that in terms of how much is being adopted. But there's also a risk. And often when we see people move to open source, they do it because they want to have an economic benefit. We did a survey last year, again, I'll talk to you about it in a minute, and I was gutted. I was really upset that the main reason people use open source is cost saving, according to our survey. So if we look first at that cost saving piece, they do it to avoid lock-in, they do it because they think they can recycle and reuse software. That's not going to happen if you throw software over the wall onto a repo like GitHub, stick an open source license on it and don't touch it. If you don't have the good governance, if you don't have the good hygiene, if you haven't got documentation, if you haven't got a way of stewarding that code over time, if you haven't got maintenance, it's not going to be usable. So, you know, you're wasting money. So I think open source, we have to start to acknowledge that it's more than that strict definition, but we also have to remember that that strict definition is what we should be writing down when we do. And as we look at this sort of rise in open source, where has it come from over the last decade? And I have three things that I think have really caused it. I think the first is the rise in the status of the developer. So I used to work very hard at Canonical, and I worked very long hours with people in the US, and I spent 5 years of my life becoming a parrot. And I became a parrot who could explain why open source wasn't the risk that other lawyers and procurement people thought it was, and it was quite exhausting. That's not needed anymore. To get open source into a business, you no longer have to go through legal and procurement. The developer chooses. And the developer is able to choose to some extent because they have the access to open source software on Git-based repos. So before we had that, you couldn't do it. And it was a very different market selling services around open source and persuading people to use it. So we've seen this shift with the developer status elevating and their ability to just choose what they want to use, which is a great thing. It's also open to abuse, which Peter mentioned, where you have this, I think it was Mongo who described open source as a marketing tool. If we talk about what open source is, I'll accept lots of things. I'll accept that it's a socio-political movement. I'll accept that it's a methodology for development. What I and anybody who has any understanding of open source will never accept is that it's a business model. And that's been public, and that's been in reports since 2008. Matt Aslett wrote a 451 report in October 2008, and the thing that was identified there is open source is not a business model. So for the last, 2022, 14 years, we've all known that. And anybody who doesn't build a business understanding that hasn't done their homework. So if I go back to what it is that has changed, the third thing, and again, Peter and I picked up on the same image. This is an image that Dan Cohn created. Sadly, he's no longer with us, but for Cloud Native, and I think Peter's is much more up to date than mine. But when you see the scale of open source in the cloud space, it's just an inevitability. Now, fangirl picture, but, and sadly, I normally get a new one every year when I go to the Open Source Summit. I haven't had one for a couple of years, it's a little bit out of date. But don't listen to us. When I joined Canonical, public enemy number one was Microsoft. Bug zero was the destruction of Microsoft. Microsoft CEO, Steve Ballmer, talked about open source being a cancer. We live in a different world. I think Microsoft is probably the biggest single contributor by lines of code to open source today. And this is my mate Steve Wally at Microsoft keynoting Open Source Summit live in Edinburgh. And he explains that as being down to three reasons. And the reasons are that today customers ask for open source because they know it's the best software. Microsoft runs a cloud product, you might have heard of it, and you can't do cloud without open source today. And the third reason he gives is developers, and particularly the younger developers who've never used anything but it and the methodologies that go around it. Now that comes with some challenges around skills and learning, and I sort of feel that we've in some ways failed that generation. We haven't passed over all the information that the early stage open source people had about why things have to be done a certain way. And that skills development is something that really needs rectified. You know, if you read, Matt Acey talks about this being an inevitability and that the young developers aren't interested and they don't care. And I totally 100% disagree with him. I think we just haven't built that skill set for them, and we need to own that, all of us. So, of course, talking about what's happened through the Roaring Twenties so far, I've mentioned the pandemic already. In some ways, it was good for open source. I mean, we're used to working at home to some extent. We're used to dispersed working. There's all of that. But actually, when you look at the government responses to it, you see that the underlying tools bring in open source software. I'm not going to call out the British government as being a particularly good example, but I am going to call out the Germans. And they licensed their app on Apache. They had over 2,000 contributions from the community to that app because they built it in the open. And now what we're seeing is that a number of these apps and the tools for the pandemic are sitting in the Linux Foundation. Peter hadn't seen my slide deck when he did his, but many of you will be familiar with this news story. And I was quite excited about it because open source was in the New York Times. You know, that doesn't happen every day. And it was the end of 2020, and there was apparently a meeting of 7 leaders of companies that were open source, companies who had built a business model around open source, and they were very unhappy in the cloud environment because they felt that the cloud companies were strip mining their assets, strip mining their open source software. So just to make sure that I say this, I want to be really clear. When you put software out into the world as open source, that is what it is. You can't take it back. You can't say you didn't mean it. It's out there, it's open source, it's there forever. You can change later, of course, and you can make the next release proprietary, but there is absolutely nothing that you can do about what you've shared. And you have to think through your business model before you do that sharing. So when I left Canonical, I spent a couple of years working with startups that wanted to be open source companies. And they came to me and they were all fresh-faced and excited. And of course, I'd gone through Canonical, I'd gone through this whole shift to the cloud. We took 70% of the cloud market overnight. Do you think we took revenue to match that? So I knew what the score was in cloud back around 2012. I said to them, what if? So you put your software out there, and what if someone else uses it? Well, that's kind of the point of open source. Mostly they were fine. What if you put it out there and someone else makes money from it? And some of them were getting uncomfortable at that point. What if you put it out there and you make some money, or even you make a lot of money, but somebody else makes more? And at least half of them never came back to me. And they were right, because if you haven't got a business model that you're going to be comfortable with, that's going to sustain, then you shouldn't open source the code. You should think long and hard about what you're doing and understand what you want out of it. And we saw the opposite of that happening. Clearly, whoever advised Elastic didn't take them through the what-if theory. And they came in early 2021 with this doubling down on open part 2. Now, it's absolutely fine if a company doesn't want to do open source software. I think they're making a mistake, but that's up to them. And if a company doesn't have the right business model, because open source is not a business model, to sustain their business whilst distributing open source, they shouldn't. They should be proprietary. But the real issue is that we've had this spate of disingenuous, to use a lawyer's word, activity. Calling a clause the commons clause gives the absolute implication that it's part of the commons. So if what it does is make code proprietary, that's misleading. If you say you're doubling down on open, I had to look up what that term meant. It's now very, very popular in the UK, but I'd never heard it before. And it apparently means that you're playing some sort of football game and you're doing something and you're really committed to open. That's not what this is. This is a shift away from open source. And unfortunately, despite much of the debate that goes on, something is either open source or it's proprietary. There is currently no in-between. Now, that doesn't mean that we shouldn't have an in-between, but somebody has to go and invest in that. And it will take a lot of energy and a lot of money to create the movement for public source, shared source, whatever you want to call it, not to be proprietary software. Right now, it is very clearly proprietary. And we see this sort of business attack and, using open source as a marketing tool and shifting away, lift and shift once you've got to a stage where you've made enough money or you've locked your customers in. But that's not the only attacks that we're seeing. There's a real problem coming to the fore right now with standards. And what we see here is another attack on revenue. So a lot of the pushback we get around open source in business is around revenue. And of course, it's disruptive, right? So it comes into your sector, you think this is brilliant, I've got something free, I'm going to use it. With a bit of luck, you learn about hygiene and compliance and you do good governance. But if you have a revenue stream that's disrupted by that, you're not going to be happy. And what we see is patent licensing making a lot of money for companies in the mobile network operations and in the SOC and other spaces. And their standard essential patents that sit within their closed standards are problematic. And they're problematic because they require something more than the open source license for the open source to be used. And the real issue is that the companies who are coming to the table are massive, they have a lot of money, they're bringing lots and lots of resource to argue this battle. And effectively what they want to create is something that I would call frowned source. And it's kind of like open source apart from my patent revenue. And it's just a real problem that we all need to be aware of and ready to take on. And the challenges that we see in open source are broader than just business models. We have this security piece, and let's own the elephant in the room. I'll start by saying that security is not an open source issue. Security is a software issue. So as we digitalize, we have to look at security for all software. The US has taken real leadership, and that's to be admired. The Biden order last May, OpenUK responded to that, looked at supply chain, asked for SBOMs in open source, which is exactly the right thing to do. And then we saw Log4j, and we saw the impact of that. But how are we going to do this? And we've seen the US government last week had a second meeting with the OpenSSF and Linux Foundation, about 50 people in the room, I'm told. Very US-centric, but looking at how do they fix it. And I think there are tens of millions of dollars going into this 10-point strategy. OpenUK is also a member of OpenSSF, and I think it's great. But what we need to be really clear and really sure about is that we have an international, joined-up approach to fixing these problems. Because again, it's not local source, it's open source. And we all have to have skin in the game on this. And it is, as I say, because we're seeing national infrastructure across the world move to open source. So back in January, I was part of an advisory board to this energy digitalization task force for the UK. And it recommends that the UK energy system infrastructure is moved to a spine, a digital spine built on open source. We're just going to see more and more of this. And what it means is that we have to think about how we fund. And that funding, I think, has to move. Not only does it have to be internationalized, not only does it have to involve governments, but we have to start to think about what open source is. It's in the Commons. The Commons Clause is not, open source is. But then you start to look at public good and the role that open source is playing in this digitalization of all our national infrastructures. And we have to think about how governments are going to fund it. We have to think about sustainability. I said we had an event at COP26. We're going to host a one-year-on event in October. And at that, we delivered a couple of things. We delivered the open source strategy, and we delivered a blueprint on the data center of the future. At this year's event, we're going to deliver an EV charging blueprint entirely built on open source, working with a Dutch organization. And of course, I mentioned the other things that we've been going through in this digital roaring 20s and the war, which has already been referenced a couple of times today in Ukraine. And I think this was either the 8th or the 12th of March. It was a Twitter call. Some of you might even have been on it. There were about 800 people listening to developers in Ukraine. And I tell you, it was heartbreaking. So Anne and I were talking before about how to do this without crying. I'm a crybaby, and I'm trying not to. These young men were not coding, they were taking up arms, and that's what they were having to do. And we wanted to do something to help them. So we set up an open source link with the Red Cross to try and take donations. It's technically a UK link, but anybody can contribute to it. And we've been trying to help a number of women developers get out of Ukraine and come to the UK. Other people took different approaches, and there is a bit of a problem here. So open source does not discriminate between fields of endeavor and between people. And what we've seen is this protest where open source won't work in Russia. And one of the hardest, I'm going to cry even more, sorry. One of the hardest things I've ever done was say no to a friend in Ukraine in April. And what they were doing was looking at how to make this software not work in Russia. And of course I said no, and it wasn't easy. Unfortunately, we now get to move on from the war. I've mentioned a couple of other things that have come up through the pandemic, and of course there's this belonging, this diversity that's really important. Open UK is an organisation that's really flourished in the last couple of years. I'm very proud to have led it through that phase, but it's not about any one person. It's about this UK leadership and global collaboration. And we have 2 staff, and we have all of these good people who some of you will recognise as international leaders in open source, who work with us and volunteer their time. Many of them are currently at KubeCon. And what we do is we look at 3 things. We look at community, legal and policy, and learning. And on the community side, we showcase what's going on in the UK. We have awards. We bring people together to give them a voice. And we use that to influence legal and policy. And we do that by responding to legislation in the UK and Europe. We've been recognized quite early stage in Europe. We were part of the Google Oracle litigation in the US. We put in an amicus brief with some other open source companies, and we responded to the Biden ordinance. Last year, we created 3 phases of reports where we looked at the data that was available that had never been cut for the UK before, and we showed the numbers and the level of open source adoption in the UK. And we did a survey that supported that, and lots of brilliant case studies. And this is the kind of data we got out of it. And what you see here is using formula that I don't like that came from the commission that looks at sort of total cost of ownership, number of developers, number of lines of code, which I think is really old school. I think it's old school because it looks at this equivalency through total cost of ownership rather than value added. But on that, we can show 20% of the digital economy is based on open source in the UK. I suspect it's nearer 60. We also know, although we can't prove because the stats haven't been shared anywhere, that as we Brexited, Europe thought that it went from 490,000 to 260,000 open source developers. So almost half of them are in the UK, which is partly why it's been possible for us to have the reach we've got. Now, for anybody listening, I suspect there are more listening than in the room from the UK, please complete our survey. Anybody based in the UK can do it. If any of you have colleagues in the UK, please share it. What it does is start to ask questions that have never been asked before around this governance and good hygiene that I've been talking about. And the last thing we do is we work on learning and skills development. And we've distributed about 8,000 of these little gloves. And the gloves are based on a software glove by the singer Imogen Heap. Ariana Grande toured with the glove. So we find that it has a real attraction to young women. And we've created 2 courses that are available Creative Commons. The second one in particular appeals to me because the 10 lessons are based on the 10 definitions of the open source definition and the Sustainable Development Goals. And it's all done in a very light, fun way. It's all animated, completely Creative Commons. If anybody's interested, take it, it's yours. And you can work out how to make the gloves online. We also were runner-up in the GNOME Community Challenge. And I just wanted to show you what a small grassroots organization like ours can do. So we work with an amazing press agency, comms company, OneBite, who have helped us with this. And we have this Twitter impact that's way beyond our size because of the great people we're made up for. So what I would say, just to conclude, is that we've managed to achieve quite a lot as a small organization. The battle is still ongoing. The war is not won. And for open source to really take the pride of place that it should in the next decade, it not only has to be the open source tiger this year, but it has to roar through the next decade. And that requires all of our global collaboration. Thank you.
Please welcome to the stage Donnie Burkholz.
Thank you, Amanda. That was fantastic. And I think it really brought home that idea of think global, act local, right? Wherever your local is, and tying everything that we're doing here in the open database community to open source as a whole, and how that ecosystem continues to evolve and needs to modernize, right? And that modernization is important, especially for a lot of the open source projects that have been around for decades. How do you keep that moving forward? How do you make it accessible to the new developers, the new DBAs, the new SREs who are entering our community today? So I'm going to talk about products. Many of you may not know me because I've spent most of my life, most of my career in the developer ecosystem, working at companies like Redmuck, working on open source projects like Gentoo Linux. In fact, I just looked up as Amanda was talking, my first open source contribution was almost 20 years ago today. I wish it were exactly 20 years because it'd be a little bit cooler. But it was more than 19. It was on April 9th, 2003, and it was a forums post. And thanks to the engagement from the community that I got as a result of that, it snowballed into me spending more than a decade of my life working on open source software on the side as a volunteer, which eventually turned into the long-term career that I've now spent. So I've spent a long time in and around these spaces. I'm spending this just telling you about this so that you get to know me a little bit, and you get to know that even though my title has product in it, I'm not the business person in a suit. I'm coming from the community, and I care about making the community sustainable and building sustainable businesses around it. And so I'm going to start out by just painting a picture of the future as I see it, which there's three main components of this. The first is that it's connected, right? There is no being completely disconnected anymore. Everything is getting only more and more connected, which makes some things more important, like the GDPR, for example. If everything is connected and everybody's data is everywhere, then respecting privacy, having good guardrails in place only becomes more and more important. It also means integration becomes more important. Everything has to tie together. When you think about what a typical enterprise's environment looks like, it's complicated. There's not only one technology stack, there's probably 5, 10, 20 or more. There's not only one database, there's not only one cloud. Things run in multiple clouds, they run on premises, they run in multiple different technology stacks. They're hybrid cloud, whatever that means, right? The point is it's complicated. Things are running everywhere. And everything connects together as well between software and services. You can't succeed with just software alone. You can't succeed with just services alone. You need everything together to help a customer succeed with trying to implement, in our case, databases and data platforms. Second, the future is intelligent. Now, I don't want you to think when I say this that it's the same tired trope you always hear, which is that AI and machine learning is the future and we should all go jump on some kind of deep learning course. No, this is about all the different types of intelligence. All right, it's about bringing together the expertise, the intelligence that's inside all of your heads. How do you make that visible and transparent? How do you make that accessible to everybody you're working with? And how do you connect that to software as well? What happens so often is that intelligence inside one person's head, the best DBA at their company, it walks away with them when they transfer to a new role, when they change to a new job. It's all gone. All that implicit knowledge, all that tribal knowledge inside of their head about their company is gone. The same is true for communities. Sometimes you have community leaders who just understand how things are supposed to work, all the cultural mores and standards, right? The old guard, if you will, who there's principles that have never been written down in a community, and yet they're true. And you have these people who have been around for decades who enforce those principles and say, this is how we work here. But in many cases, it's never been written down. And that intelligence is really important to write down, share, so it's not lost. And it is about automation as well, right? Of helping make our systems more intelligent so that they stop people from doing the wrong thing by accident. How do you help things not go wrong consistently, especially as we get bigger and bigger scale, right? Data's never getting smaller. Database environments are never getting less complicated. They're only getting more complicated, more hybrid, more diverse. And we need more and more automation to help us succeed in those environments. Because there's always a corner case that's going to slip through somehow. There's configuration drift that's happening. There's somebody jumps into a server during an incident, makes a change. That change never gets replicated, never gets scaled out. And it's lost or it's maintained, and that one is always different forever. And so how can we take advantage of more and more automation to help us do the right thing and focus our time on creating new value rather than our time on responding to tickets. All right, I spent a few years at an enterprise myself, walking in the footsteps of all the customers that the vendors are trying to sell to, and for those of you who are end users, making sure that I understand your pain points. And what it felt like was just constant toil, just trying to keep up, right? There's always pressure to decrease budgets, cut your costs year after year if you're in an IT department, and at the same time, you're being overwhelmed with these tickets. So how can you take advantage of more and more intelligence to keep up? And finally, the future is open. That's why we're all here, right? It's open source. It's keeping that openness real in a way that matters. How do you have open source not just be a marketing term, but be something that is true, that is real, that is authentic, where you can pick up open source software and you can use it in a helpful way. You don't have to go pay to get value. You get value out of that freely available version of it. You can go grab it from GitHub, download it, install it, and it's giving you something useful. It's not giving you something where you try it and then you just feel that pain of, now I have to go pay. It's open standards, right? Of how do you have things that work together consistently at scale? It's using standards. In our case, you might call SQL a standard. It says it's a standard. It doesn't always work consistently across different environments, but it is the lingua franca of databases, right? Every time there's a new database that emerges, at some point they almost inevitably go back and add SQL. Because tying into what Amanda said about how developers are influencing technology choices, this means that the barriers to entry are more important than ever. And open is one of the biggest ways we get there. How do you make it as easy as possible for people to adopt new technologies? Because if developers are the influencers, if they are the kingmakers, as my old colleagues at Redmonk would say, they're going to go whatever way is easiest. And if we make it too hard for them to go the approved way, the default way, they're going to find another answer. Now, we've been talking about the future, but what about today? You know, it's great to have these visions of where we could go, and yet today we're so stuck. The problems, in many cases, remain the same as they have been for decades in a slightly different form. Right? It's things like performance and availability. Like Charity Majors at Honeycomb, who I've known for a long time, says, you know, it doesn't matter where your database is running or who's running it for you, you still own the performance and availability for your application. You don't get to outsource that. Your customers, your company's customers, do not care. If you say, oh, we've got a supplier who's running that for us, they don't care. They're going to leave you because you chose the supplier, you created that trust in them, and they expect you to hold that trust up. It's security and compliance. It's an ongoing battle, one that is thankfully starting to modernize because we've got better tools for automation and continuous compliance than we used to. We don't now have, you know, the team in checklist who shows up once a year, once a quarter to do your PCI audits. It's getting more and more efficient and doing so in a way that helps you scale more effectively and dealing with those increasing demands for self-service. And if you're not hearing those demands, chances are that's because your developer teams have already bypassed you. They're already in the cloud doing self-service on something else, and you're just not hearing about it anymore. Because those developer teams are looking for and expecting self-service. They're looking for ways to move faster, and you're looking for ways to give it to them, but ways that don't give you more and more work. Our 2020 survey showed exactly that. The problems are the same as they have been. Right? It's availability, it's performance, it's incident response, it's security. It's dealing with all those issues continue to be the biggest pain points. And so we need to continue to take action to make those easier. Now, everybody here is from the broader open database community, and everybody has a different view on approaching that problem. Our view has been, as Peter said, has been a 15-year-long experiment now in staying fully open, doing everything we can to take open source as an experiment and say that is going to be the way we approach this. We're going to be the champions. And so we've had our great services business built around this for a long time. And we've also had open source software that we kept everything open source all the way throughout. And now we're bringing that together into something we call Percona Platform. This unifies the software and services to run your database experience in any infrastructure. And so when we think about what we're trying to do here, we've had services for a long time. We've had software for a long time. Software has been super popular. I'm going to show you some of the numbers later on. But we've never really brought that together. We think we have some of the best experts in the world. I'm happy to have a discussion about that with any of you afterwards. We think we have some of the best experts in the world in all of the databases we support. And we're applying that expertise more and more, not only to the services, but to our software, bringing all of that together into that holistic solution to help customers get what they're looking for. I'm going to show you in a little bit a couple of demos of this. So you've been in an hour of keynotes now. You might be getting a little bit tired. You might be running out of coffee. We're going to show you some real working software just to keep things interesting. And if the internet works, the demo will work. Otherwise, you get to watch a video. So when we think about what we're trying to accomplish, what we're trying to give to customers with Percona Platform, it's about giving them control and visibility. Because when you have developer teams that are looking for self-service, the first thing that might be running through your head is like, oh, that's going to go off the rails. You know, they're going to do crazy stuff. The environment's going to fall over. They're going to use up all the resources. They're just going to start up instances that are going to keep running. They're going to never shut them down. It's going to be a big old disaster. They're going to do things that aren't secure. And so what do you need to do to give them the right guardrails to succeed, but do so in a way that doesn't have to involve you every step of the way? And do so in a way that for your production environments gives you overall visibility consistently across your databases, across your environments, from cloud to cloud to cloud to on-prem, and lets you see and manage those consistently. And secondly, it's about that simplicity, right? Because, I mean, let's face it, all you know, databases are super complicated. Complicated to configure, complicated to manage, complicated to monitor. The more we can do to bring that together into one place, the better. The more we can keep people from having to jump across fragmented tool sets, the better it's going to get. And finally, it's about enabling developers to move faster. And we do so through giving them a database platform that lets them move quickly while DBAs or SRE teams provide that platform to them. All right, and this is really that mindset shift. How do we change the culture, and how do we use technology to make some of that real? We give our developer teams platforms. We maintain that platform. We provide them with a self-service experience. We provide them with enablement, support, and training. And then those development teams can go, they can run, right? They've got everything they need to succeed. They don't need to start filing another 27 tickets the next time they're looking for a new database server. So we've brought together the things that make Percona great, the things that people love us for, all in one place. The open source software and the tools. We brought the expertise. We brought self-service content, which many of you who, if you haven't been a customer of Percona, we have a great knowledge base available for customers. It's only getting more and more popular, getting more and more articles in it. We've got close to 1,000 articles in there now, so there's a lot of problem solving. And what I find, I'm right on the cusp of being a millennial myself, and I know that at least for me, I hate talking on the phone with anybody ever. If there's anything I can possibly do to avoid interacting with a human on the other end of my commercial relationship, I will absolutely do it. I will change my vendor choices if one of them requires me to talk to a human and the other one I can just go buy it. And many people are exactly like that. So they're looking for ways to do as much self-service as possible, take advantage of what you might call level 0 support to just go solve as many issues as they can, and then go to the experts when they really need to, when they need customized advice, something that's unique about their environment that's hard to solve themselves. And finally, something that is new to Percona Platform. So we're bringing together the best of what we've sold, the best of what we've always given away in open source software, and something new. And what we're bringing new is these automated insights. So we talked about the power of intelligence to change the way we work. Automated insights are the first way that we've taken at Percona to help with that. And Barrett, our Director of Solutions Engineering, is going to show you a demo pretty soon here on what that looks like in practice. So when I joined Percona, I saw this great opportunity, and they had seen it too, in how can we take advantage of that software and pull it together into something really holistic and make that more of a product offering. Now, in the past 12 months, we have seen 75 million downloads of Percona's open source software. It's a massive, massive number. And what's really interesting about this number too, just that reflects some of the comments earlier about Kubernetes, is about 3/4 of those downloads were from Docker Hub. They're containers, right? People are using containerized databases, containerized database monitoring so much that you have to make sure that somebody's doing that at your company. And if it's not you, then you want to figure out how do you get visibility into that? How do you start enabling them? And how do you tie that into your broader data strategy? Or it's going to continue to happen without you. because there's a lot of people using containerized databases right now, whether you know it or not. They're making decisions about which database they're going to use, whether you know it or not. They're doing so in a self-service way. And now, even today, 2/3 of our support customers have chosen to run the Percona stack. All right? It's not been a part of our product at all. They've used it because they love it. They've used it because it works better for their needs. And of our managed services customers, all of them use PMM because that's how we run it. So that's not a very interesting stat to share. But 58% of them have also chosen to run the Percona database. This is just great support for the value that we're trying to bring to people, to take that expertise that people have known Percona for and translate that into software as well. And here's a few quotes from some of our customers who just really love Percona software today. I'm not going to read through all of them. I'm just going to give you a minute to browse through them. These are just some examples. Of course, I wish I could share all the examples that aren't public. Right? Peter showed a slide earlier on talking about some of the customers across different industries that we have. And this is one thing that when I joined Percona, I was amazed by the customer list we have. I wish I could share it all. But when you talk about 9 of the top 10 tech companies coming to Percona for our expertise, that's something that is so flattering. It feels really amazing to me. And this is a little bit of a humble brag, but I'm going to go with it anyways, because it just was it was a shock to me. Because I knew Percona for their expertise, but I didn't realize how much it meant to people who are leading the forefront of innovation in the tech industry as well. So what does this platform look like? I've been waving my hands around for a while talking about this Percona platform thing. What is it? In our case, I'm going to walk through this top to bottom fairly quickly, and I encourage you to come to our full-length session that will be running tomorrow if you want to learn more about it. We've got PMM, which really we see as the heart of the platform. It ties everything together. It's got both monitoring components. One of the most loved part of that is something called Query Analytics, or QAN, which gives people a great way to really dive in and identify the most problematic queries that are running. It's one of the reasons that people run PMM today. We've got advisor insights that are new. These are these automated insights. You're going to hear a lot more about those in a couple of minutes from Barrett. And then it's also got management, which we've been making a lot of investments over the past couple of years to improve our management capabilities, bringing you things like graphical backup and restore, which we're going to GA fairly soon here, an inventory, private DBAS, which you're going to hear more about in a little bit. And we've got the database distributions, which is not just the database server, but really everything you need to succeed packaged up in one place. Percona Extra Backup is one of our most popular pieces of software. People use it regardless of which vendor they're using their database from, because it just works really well. Similar is true for Percona Backup for MongoDB, which we've got some really nice additions for. Hopefully you make it to a session if you're a Mongo person here. And then we make sure that all these database distributions include the backup, include what you need for high availability, what you need for security and audit logging, so that all of that is available open source. We just had a roadshow event a week or two ago in Sweden, where one of our customers went on stage, created their own matrix of decision making, and showed just item by item why they had chosen to run Percona software. And every one of those was because we had been publishing features, we had been publishing enterprise features in the open. Finally, we've got Kubernetes operators. We've got operators for all of these databases. They're all GA. People have been running them very successfully in production. We invested a little bit early, I think, for stateful databases on Kubernetes. That was a place where people were not ready when we started working on it. We invested ahead of the curve, and fortunately, that community has continued to grow. That momentum has continued to grow, and that's really reinforced the investments that we've made in it. Now I'm going to bring up our Director of Solutions Engineering, Barrett Chambers, to show you more about advisors.